And we are now streaming on YouTube, and we'll get started in 1 minute. And I'll turn over sharing to. Okay, DCO team, you've got it.
Hi, I'll kick off. My name is Trevor Butterworth. I'm just going to be very quick and to get things started. We're very excited to bring you this workshop today. Thank you to everyone for joining. We have a great group of instructors to talk you through the Hyperledger projects that are currently being used all across the globe to build decentralized identity solutions. The work of the open source community is super important here because more and more enterprises and governments are requesting open source solutions for identity and verifiable data issues. Today, we're being joined by some of the people who've been there from the very beginning to build these open source code bases. So you'll get their insight and their experience, and I encourage you to use the Discord channel to ask questions, as David has already indicated. You can also ask them in Zoom, but the Zoom chat panel isn't going to be permanent, whereas Discord is forever, so to speak. Prior to today's workshop, you should have received some instructions. If you haven't done that or you haven't got them, don't worry. You can follow along and, as our instructors run the demonstrations. Today's workshop will be recorded and available on the Hyperledger Foundation website in the training section, along with instructions and links to all of today's materials. So feel free to access this at your convenience. So we hope this is going to be a great resource for you to get up and start building your own digital identity solutions. And with that, I'm going to hand it off to Scott Harris, who will be leading the first session of today's workshop.
Thank you, Trevor. I'm apologizing for a little bit of screen sharing tech issues there. So we're going to just look at it this way. And let me make sure everybody's seeing our title slide here, Build Your Solution.
We can see it.
Excellent. So we'll just move through it this way. That is James Schulte, who was here last time, and Director of Business Development, and someone you can reach out to for questions, amongst others on our staff here. We have a link to the workshop materials that we will share in the chat as well, and at the end of the session also. So if you would like to review the materials presented, that'll be available to you as well. And Trevor, you may know is our chat is active here on Hyperledger during the workshop.
Yes, it is.
Excellent. Okay, so feel free to jump in there. My role today is to talk at a very high level about what decentralized identity is, how we approach some of the concepts, and do a level set on how we think about things and some of the terms and definitions that we use and that you'll hear throughout the day. So for those of you that are intimately familiar, we hope it's refreshing and perhaps a slightly different look at things. And if you're just coming into this sector in this industry, we'd like to get you started down the right path and thinking about this in a way that's useful and productive. So I am VP of Business Operations here at Indy. I do many things. One of the things is education along these lines, and one of them is problem solving at the client level and working through UI, UX, and workflows and governance challenges and things of that nature. So I talk about this quite a bit. So let's jump right in. This is a very old cartoon that describes some of the problems we have with the interactions and relationships that are digital, that happen across a distance via the internet. And the anonymity of the internet can be a great thing. It's can be a great way to protect privacy and do things without revealing a whole lot about yourself. However, the downside to that, if you're looking to execute some business function, is that we often need to know who's on the other end of a transaction, both for the businesses, but also for the end users transacting with the business. So you'd like to know for certain that when you send a payment or you submit some PII somewhere, that you're submitting it to the place that you think you're submitting it to. So anonymity is a double-edged sword, and we need a tool or a technology to solve for both things, something that can positively identify the participants in a transaction or verify some data points, but also protect privacy where applicable and where needed to help protect everyone's individual data rights. That's what this technology is really intended and evolved to do. We have identity systems to establish trust between parties. And if you have a LinkedIn profile, you might have signed up for it using a Gmail address, and you signed up for that Gmail address doing absolutely nothing to prove who you were. And therefore, we are in a system here where despite all the 2FAs and 3FAs and things of that nature, the original root of our entry into a system such as this is not supported by really anything whatsoever. So it's very easy to pretend to be someone you're not. And we intend to solve for that. And let me get myself down there. So what is identity anyway? We'll try to talk about the second part of our technology, decentralized identity. And typically when you ask someone what identity is, they will give you these sorts of answers, a person's name or a date of birth, perhaps something about their life or their educational credentials or something like that. So biographic and demographic data is typically how folks define it. And that is a very useful set of information for transacting things digitally. However, it's not the be-all, end-all of what decentralized identity is. And we have started to refer to this type of identity, the biographic and demographic, with lowercase I. And certainly a bulk of the use cases that have been built out on this technology to date have dealt with these very things, biographic and demographic data points. So where do these data points come from, the lowercase I identity? Well, they can come from anywhere. Not just your typical driver's license or passport type of things, or your employer even. They can come from interactions that you have, anywhere you've established some footprint or digital trail of yourself. And any given data point that can be used to prove something about yourself can constitute part of your identity, as long as that data point is valuable to the party that's receiving it. If they've determined that receiving this data point will help them establish trust between yourself and that other entity, then it can be used to prove something about yourself. So we start to see that your identity can become, well, almost anything that you and some other party agree that it is or it needs to be. And then when we expand our view just a little bit further, we have identity with a capital I, which is that any data point that can be valuable to someone who receives it and can be shared with consent. And that's a subset of potential identity, which is any conceivable data point. So when we widen our view far enough, we see that identity, as it's used in our decentralized identity moniker, can really be absolutely anything that you want it to be. If that data point is valuable and useful to someone who receives it, then it can constitute part of an identity. And the key, of course, is validating or verifying that data point for certain features in order to be able to trust that data point. So rather than things being rooted in no verification or no validation and no trust like they were with your email addresses, we can use this technology to prove the validity of these data points. So when we look at identity as being everything, we can widen our view a little bit further away from individuals and out to things like businesses or governments or operational entities, devices and IoT things and physical objects have identities as well. So if you think about a vehicle with the VIN number or a license number, a registration, maintenance records, business with all of their financial reports and business records and employment records, all of those are simply subsets of this potential identity circle. Any data point that might be valuable to someone that receives it can constitute an identity. And then once we use this technology we'll talk about today to package it up as a verifiable credential and send it on its way, it can smooth business processes and operations to the point where it becomes very, very valuable. So we'll talk for a second about decentralization in our pieces of pie that constituted someone's identity. All of those things I showed earlier as touching each other. And that's a bit like the world we live in today, where you might use an establishment of trust, let's say a Google account to log into something else, or a Facebook account to log into something else. And all of these things touch each other. Or you may submit some information to an entity who then goes sort of behind your back and checks it against some other entity's database, and they're talking to each other, probably with your consent, maybe or maybe not, but that's a question for the legal experts. But the problem with that centralization is that this data is being handled sort of around and about you, but not with your explicit participation always. And in that sense, it's difficult to track consent compliance, and it's difficult to have transparency. And in the GDPR world that we live in today, even if you're in the US, there are problems with that, certainly for businesses. The other big problem for business here is that integration of systems that's required to do this centralized model are very, very costly, and they're difficult, and they sometimes compromise privacy. And of course, there are security issues. So, when someone gets into one system, they may be linked to dozens of others and gain access. So centralization has a lot of issues that could be solved for with some appropriate technology. What we're striving for with the decentralized model is essentially a digital model of the analog world, wherein you might be given some set of data about you. In this case, we'll look at a driver's license because it's an easy to conceive of example. You're given a set of data and you hold on to it. And when it's time to show that to someone, you take it out of your pocket, so to speak, and you show it with consent, and then you put it back in your pocket, and it's still yours to hold and carry around, rather than things being shared or moved around for you, in essence. So we'll take a second for a history lesson here and look at trust in the past and trust now, because we've talked about trust systems and identification systems. In the analog world, from the time of the first recorded writing to about 1964, we had physical objects, and physical objects have a means of determining whether they're trustworthy. If you think about a driver's license or a passport, a birth certificate, even a registered or notarized letter, they've got some means whereby when someone receives them, they can look at this thing and decide whether it's trustworthy. They can look for the eraser, they can look for the whiteout, they can look for alterations and things of that nature, and they can look at the special paper or holograms or things of that nature to say, hey, this thing is real, and therefore I can trust it and move you forward in the process that I'm trying to move you through. And then we get to about 1964, when the first fax is sent. And now we've got someone taking a real object, putting it on a screen, sending it digitally across space and time, and it's being received on the other end in an output format that is not the real thing. It's a facsimile of the real thing. And yet the receiver of that treats it as if it's real. And in doing so, they assume a lot of risk, or some risk. and even some risk is more than they assumed before when they saw the real object. And if they don't want to assume the risk, they've got to do a lot of work to mitigate that risk, to go and actually talk to the source of that original document and find out if it's real. And so in the hybrid world, we've actually reduced the amount of trust in an exchange of information or identity credentials, if you will. It is more efficient, certainly, at least in some aspects of the exchange, and it's definitely a sacrifice in privacy and control for the individual that holds those things. In the decentralized world, we are able to maximize trust, maximize efficiency and privacy by using the tools and technology that you'll hear about a little bit later on today. So why does it work in analog life? Well, much in the way I described. We have trusted issuers who give you a physical credential and then you hold them, and the verifier of that can visually check whether the thing is real or whether it's been altered, and then they can make a decision about whether or not to trust that document. When you upload a JPEG or a PDF to apply for a mortgage or open a bank account or travel or any of those things, the entity that receives it is just getting a JPEG that you could have certainly created in Photoshop. And now they've got to do a lot of work to decide whether it's trustworthy. So we're going to solve for that. And that's what I just described here. There's all that work and all of those questions that arise when you upload something or email it or otherwise transmit it digitally in the methods that we have in use today. So what is trust in data? Well, trust comes really in three parts. One is authenticity. So if you receive some data, you need to determine whether it's authentic. In other words, where did it come from, and does it come from the place it claims to be from? So we can use the ledger to support claims of authenticity and verify that something did come from the place it claims to have come from. In other words, you didn't make it in your basement. And then we have also data integrity, which is about whether or not that data has been altered. So if you have a driver's license, for example, and the physical thing has some lamination, and if it's delaminated and has cut marks in it, it's probably evidence that you've tampered with it in some way or another. The PDF upload of your driver's license doesn't have easily identifiable integrity marks in that way. So we can provide data integrity with this technology as well, and evidence that something has arrived intact as issued. And then the third part is usefulness. So this is more of a governance and decision-making and business logic question. However, it's really the essential part of it. So for someone who receives some credential data, they need to have a contractual and conceptual understanding about the issuer of that credential and understand whether or not they want to trust it. So a simple example here is if I transmit a driver's license via a credential like this, and you can confirm that it came from the licensing organization, then it can be very useful to go rent a car. If I give you a driver's license that came from the local coffee shop, who could potentially issue you a driver's license using this technology, I need to understand that it came from the coffee shop and not the driver's licensing entity, and therefore not to hand you the keys to the rental car. So that's one of the things we really focus on here is usefulness and trust decisions, and those are governance things, and we'll talk a bit about how we execute those things from the tech point of view. The trust model consists of two parts. It's the cryptographic trust. So much of the stuff that you'll hear about today is cryptographic trust. It's talking about how we use the ledger and use the Hyperledger tools to support claims of authenticity and integrity. And that's pretty straightforward. Most organizations will trust that. If you can adequately explain it and articulate how it works, they'll say, okay, I do trust the tech. And then the philosophical trust is what I just described. It's, hey, I essentially will give you the keys to the car for a real driver's license, but I won't give them to you for a driver's license that came from Joe's basement driver's license organization. And it's certainly possible for Joe to go and issue driver's licenses. And so we need a mechanism for the rental car agency to decide whether Joe is trustworthy or not for giving you the keys. We'll talk quite a bit about credentials in this format, and it's a very simple look at it, but at Indicio, we approach all of our problem solving in this way. We look at issuers of credentials, holders of credentials, and verifiers of credentials, and then of course their relationship to the ledger and the the networks that support these. And there are a lot more on that, of course, later today. The key to this, though, is that we write things to the ledger to support data authenticity and integrity, but we don't write PII to the ledger. We only use these ledger-based items or objects to support those claims and those proofs. The data itself goes from the issuer, who has it normally, and directly to the credential holder, who has a legal right to have it, and then with consent goes to the data verifier. So again, an important point here is that no personal data, no PII, no credential data, whether it's PII or not, ever hits the ledger itself. And of course, the question to trust or not to trust once you receive it. I'm going to skip through these use case examples a little bit in the interest of time. I've talked a little bit about it. But the building blocks here that we will speak of today, the vocabulary used is one of agents. So we'll have an issuer agent and verifier agent that can be stood up in a number of different ways as cloud hosted or even on-premises type of instances, often with the web UI associated with them. We'll talk about edge agents, which are mobile devices, laptops, things that come and go, things that go into airplane mode or lose battery or just get turned off. Typically, we would use edge agents for holders devices and for people to hold credentials, or sometimes for mobile verifier agents. And of course, all of these talk to the ledger in their own way. And then we'll have mediator agents as well, which act basically as an escrow to hold these credential exchanges and messaging between agents in the case where these edge things are offline. I've used these words before, but just a quick level set. Issuers are those that create and package a verifiable credential and issue it to someone or something that's going to hold the credentials. And again, a reminder that the someone, even though it's a person up here, might be a business entity, it might be a government, it could even be a custodial holder whereby you're the business that holds the credential that actually belongs to a car that your business owns or something of that nature. And then we'll talk about verifiers. Verifiers are those that receive the credential data or the credential itself and then check against the ledger for its authenticity and integrity and then make trust decisions. We'll use the sort of typical Bob and Alice names that you'll see over and over. So in most of our conventions here today, Bob is an issuer and Alice is a verifier. And then the thing that's often overlooked is that these roles are not mutually exclusive. We need not have issuers, holders, and verifiers as three separate parties. Many of the use cases we built into DCO have been closed ecosystem use cases where an issuer is also the verifier of their own credential, and the credential can be used by a holder to gain access. It can be used in identity access management things, physical plant access, proof that you need to go get a pay stub or get some service from your own employer. It can be a situation where, let's say, a bank issues an account holder credential to you, and then you use that to get back into the bank to access your account. So just keep in mind that the roles, although we'll talk about them mostly as three separate things, are not always mutually exclusive. And then, of course, to bring it back to where we started, the code architecture. So we have Hyperledger Indy, Aries, and Ursa at work here for you today, and that's not my role to talk about how these play out. That'll be coming up shortly, but this is why we're doing this here with Hyperledger. They're a great partner, and we have a lot of great resources to help you navigate all of this. So that is my level set on where all of this comes from. And I'm going to now turn it over to Sam Curran for some info on community.
Thanks, Scott. Appreciate that. Let me get the share button to behave. All right. I'm talking about community engagement. We're going to talk about some the technical stuff of and start with Indy and then in Aries and talk about how it ties together. But first, we want to talk about engaging in the community. Hyperledger is an open source foundation as part of the Linux Foundation, and we are a community that gathers together and works together to make these things work. And so I'll talk a little bit about that. I am Sam Curran. I'm an architect within DCO. And I work with the Aries working group very heavily, and also the Didcom working group as well for the spec development there. There's my email address, and I am Telegram Sam on all the socials. So if you want to connect with me, please reach out. I'd love to hear from you. Why would you engage? There's a handful of topics here, and I promise I'm not going to read all my slides. The one that I really want to highlight here is that when you engage with the community can be more aware of the types of use cases that you are trying to serve, and that can help the community be more aware of that and help guide and include your use case in the types of projects that will be well supported. That's not the only reason, of course, but that's a really useful one. There's oftentimes, communities benefit from people coming and sharing how they're using the technology, and that's a learning experience for the developers and other maintainers, and can help the project improve and be substantially better. There's other reasons, of course, in contributing and everything else. The other thing that I really want to highlight here is that this is we think about open source as developers, and that's true. Developers are really useful, but there's so much more to be done, and user experience design, documentation, project managers, people to organize efforts. There's all sorts of folks needed in all of the projects that we'll be talking about today, and that is and so we need you, even if you don't fit a strict developer mold. We hope that you will come and join us in our efforts. There's three plus projects that we're going to be talking about today. The Hyperledger Aries, of course, is a little bit of the main focus, but that's supported by Hyperledger Indy as a verifiable data registry underneath. Also, Hyperledger Ursa is the cryptographic portions of what we're talking about today, and just barely, we have the new Hyperledger AnonCreds project. This logo came in just a couple of days ago after being approved by that project. And AnonCreds is a way of expanding the verifiable credential formats that Indy has used so that it will work not just on Indy, but also in other environments as well, which expands its potential for use. And so the 3+, now 4 projects that kind of form a cluster of the functionality that we're going to be talking about here today. So all of these projects are great and focus on different aspects of what's going on, and all part of the Hyperledger Foundation. There's the Decentralized Identity Foundation is another organization that has some good stuff going on. They have interoperability working groups. I mentioned the Didcom working group that I'm a part of. Also identifiers and discovery and claims and credentials, etc. And they can be available. They can be found at Identity Foundation, and they're doing lots of good work there. Trust over IP is another organization that has been involved in a handful of different aspects. The trust over IP layer model is also an incredibly valuable sort of way to think about the different types of both cryptographic and human trust that are involved, and so they're another useful organization to be aware of. The W3C Credentials Community Group has focused on the DID core spec as an output of that particular group, which we rely on for the aspects of the puzzle that it provides. And also the W3C credential format is a popular format for credentials, and there's an existing one there, and there's also discussions about the next one that are going on in that group as part of their work. So there's all sorts of different working groups all over. I just highlighted, of course, not just Hyperledger, but 3 of these other organizations, and there's a few others. And all of those have multiple working groups. And so each of those working groups communicate. I'm going to talk a little bit generally about how these groups tend to work to help you get familiar with them and find it easier to get involved. The working group communication usually has several different aspects. There's usually a chat via Slack or Rocket Chat or IRC, so that you can ask a question anytime. There are email lists, and those are often better for sort of longer form discussions or things that are happening. And then a working group calls are very popular for joining together and asking questions and learning. And that's often a really good place of learning because it's very organic. People can ask questions and discuss things, and so the calls are very valuable there as you're getting involved. Calls are, of course, being a big aspect of it, have a couple of common elements. There's usually an antitrust policy that's present in calls and a code of conduct. And the reason these exist is to help us collaborate with each other and not cause any legal issues with what's going on, and of course to be excellent to each other and to make sure that all are welcome and represented. And these policies do contain typically information about how to resolve issues that may come up. In many calls, these are highlighted or they're linked to in the agendas to make them very easy to find. Luckily, these types of issues are really rare in the community, and so it's a very healthy place to be. But they do exist on purpose, and they're available for use whenever necessary. Meeting agendas are a powerful thing that help drive calls, but also help you be available or know what's going on if you happen to miss a call. So to be aware, topics are almost always welcome in any of these calls. If there's something that you would like to bring up, to ask, or to share, or to present, or even if you don't have the answers but you want to bring up a scenario and learn more about it, those are almost always welcome. And just contact the chairs or the coordinators of the meetings, and they can help get you on the agenda. Maybe not the current one, but one coming up soon. There's various forms of interaction in meetings. Sometimes there's a formal queue where you use a command in the chat like Q+ or something to add yourself to the queue. Sometimes they'll utilize the Zoom raise hands feature in order to manage that. And sometimes it's just to speak up. The larger the meeting, the more formal the interaction tends to be. It's different if there's 11 of you there than if there's 150 of you there. And so that will vary depending on the size of the meeting and sort of the culture of the group that is organizing it. They'll almost always mention what the form of interaction is preferred to be, and you can always ask in the chat and someone will let you know. The chat itself is almost always active in the meetings, and it's a great way to ask a comment or ask a question or make a comment on something that's going on. And that could be a really useful way if you're unsure of something and don't really want to verbally speak up, but you want to ask a question. That's a great way to ask a question, and you'll find that people are pretty friendly about answering those. Calendars will help you know when the meetings exist. They're generally run by the organization that's at the top. So Hyperledger has a calendar that highlights all of the different meetings that are there. The Decentralized Identity Foundation runs one separately, etc. Links to the calendars can often be found in the repository or the agenda that's running it. Those are often on a wiki to help you understand. And so once you sort of find one of these things, it's relatively easy to look a little bit and find all of the information that you'll need. One thing I'll mention on calendars to be aware of, we're in daylight savings time shift season around the world. Most meetings are anchored in one time zone, and they will follow the time zone shifting, the daylight savings time zone shifting of the time zone it's anchored in. So let's say that's US Pacific. So the time zone shift will happen when that happens. And so if you're somewhere else around the world that either does daylight savings time or not, be aware of that. Generally, if you use a calendaring system, Google Calendar does this relatively well. If you copy a calendar event from a source calendar onto your own, it usually brings the home time zone along with it, so that it will automatically update as the daylight savings time stuff changes around the world. So about twice a year we have a little bit of a kerfuffle there that happens as people get used to that. So so yeah, lots of stuff going on like that. Excellent. So meeting recordings. I can never make all the meetings that I want to. Meetings are often recorded, and it's worth being aware of that. By being in the meeting and contributing, you consent to being recorded or to have the things that you type in chat represented. So be aware of that. Recordings are a great way to catch up, and it's really useful. Most video players will allow you to play a video or the audio back in faster than real time, which can be really helpful when you're trying to be aware of what's going on in meetings that you doubled up on, or if you are on vacation and you want to catch up later, then that's a great place to do that. Recordings are usually posted on the agenda, sometimes in another place. The Diff, for example, has a channel that all the recordings get posted into. Please ask, and people will tell you where the recordings are. Or I occasionally forget to post recordings. If you ask about a missing recording, then they can usually get that uploaded for you. And so that way you can follow up and be more aware of the things that are going on. Most of these working groups use GitHub as a way to organize things. And there's a few common elements. GitHub has a lot in it, but there's common elements that I want to highlight here that will help you be aware of how to use it. The README file that displays when you first look at a repository often contains the meeting info and also links to or contains rendered copies of the content. Sometimes there's the source files that are often in Markdown, but they can be organized into somewhere. And so if you read the README at the beginning, it'll often point to the place where you can find a rendered copy of the files that are in the repository. That's particularly true for spec work. It'll often point to the rendered version of the spec, and that's often easier to read than navigating the files in the GitHub repository itself. On the Issues tab, you'll find open issues, and these are really useful ways to help you orient with the community and to contribute or be involved as well. You want to read open issues, or you can look at recently closed issues. You can comment on issues that are important, and if there's something not being discussed that ought to be, then opening a new issue can help you to ask a question and get people to respond to those. Issues are a great way to organize conversation around a particular topic when you're trying to figure something out or there's confusion on an issue. Pull requests are updates that are active to the repository. And when folks submit pull requests, they're usually available for commentary for people to read and review them, or point out additional things that can be changed, or typos, or things like that. Any errors made in the pull request before it's committed, and that's useful. Being aware of the pull request in a community can help you understand the movement that's going on and the work that's being done. And of course, I'll talk in a minute about how to commit your own changes or suggested changes to the repository. The commit history inside of GitHub is also incredibly useful, so that you can see what has changed recently, and it'll tell you, who submitted the pull request and the time that it was, and of course you can see what the changes were as part of that. And so becoming sort of familiar with the recent history can help you understand more of how the community's going, like where it's going to, and who's contributing, and the types of changes that are being contributed. And that's helpful to understand, but not only the state of the community, but can help you understand where help might be needed, or ways that you might be able to contribute. So if you're going to contribute your code, there's a pattern here that will help you a little bit. The first thing that I need to mention is to mind the code license associated. It's often Apache 2 or similar, and you can find that often in the README or in a license file in the repository itself. And that will tell you which license it's under. And you want to make sure that you understand the license, and particularly the organization that you might be working for can help understand or is aware of the license on the repository that you might be contributing to. That's not typically a problem, but you want to make sure that that's clear before particularly you commit resources that the company has paid for in order to the open source project that you're looking at. So when you do want to make a contribution, and this is both code, and some repositories have markdown files or documentation of things, and this applies to that as well. You want to work on a repository fork. Git has the ability to create forks for temporary sort of manipulation and comparison. And so what you want to do is fork the repository into your own GitHub account, and then create a branch on your GitHub account for your contribution. You want to be aware of the developer certificate of origin requirements on commits. That's usually a setting that you can change in the software that you use, or that you can manually add. And so if you Google up developer certificate of origin, you'll find more information there. And then once you've made the change, you want to push your branch from probably your local system to your GitHub fork. And then it makes it easy to create a PR to the main branch of the original repo from the fork in the branch of your fork. This makes it easier to update your pull request if there are suggested changes. You can just change and commit it on your fork, push it to your own fork of the repository, and then it makes it easy to compare and then accept pull requests. And so pushing back to the open source code base is sort of the foundational way to support the community. I want to highlight that you don't always need to have very substantial changes for them to be useful. Some of the most useful pull requests that I have reviewed and received are in the forms of a clarification, or of a typo, or a grammatical error that's made that might trip someone up, particularly if they're not a native English speaker, and the text happens to be in English. Fixing those things can be really helpful to help people understand what the code is saying, or what the documentation is saying in a really clear way. And so don't feel like a contribution has to be very substantial. In fact, for your first one, it's useful to find something small that needs to be fixed and kind of go through this process so that you're familiar with how it works. And communities love pull requests. That's the lifeblood of how things improve. So I want to finish up with guidelines for engaging in the community. And when I say in the community, I mean any of these working groups, in any of these organizations, and in any of the forums that we've talked about, whether it's commenting on an issue or participating in a meeting or any of those things. Those are all types of engagement within the community. Please speak up. You are welcome and you're needed in the work that we are doing. We have to understand the types of problems that need to be solved by the software that we're engaged in for us to do it effectively. And please speak up, particularly if you don't feel like you fit in. The diversity of our contributors contributes to the success of the project in solving problems in a universal way that fits all of our needs. And we need you, particularly if you don't feel like you fit in. Please stay, please speak up. Be persistent with your contributions. Most open source maintainers have jobs. Sometimes they do it in the weekend, sometimes it's part of their job, but everyone is busy. If you submit something like an issue or a pull request and it's not being acknowledged, then please make a comment or raise it again, and be patient with the busyness of others. We all have stresses in life. Sometimes we're busy, sometimes we've had a bad day, and we may not all respond well. And so please be patient with us, with each other, as that's happening, and assume that people mean the best. Having said that, do not put up with bad behavior. If someone is acting poorly, is engaging in behavior that is simply not acceptable, then engage the code of conduct, seek help from leaders and other members of the community in order to push back against bad behavior and not allow that within our community. Again, it's rare, but this is something that is unacceptable, and that we need to make sure that we do not allow to persist. Hopefully this helps you gain some confidence and a little bit of understanding of how to engage in the community and the way that this can serve and be important. We're grateful that you're here at this training, and we're grateful that this community is one that you have interest in, and we hope that you feel welcome here. Again, I'm Sam. Please reach out if you have any questions or any other things that we can help you with. And we would love to help you get engaged. I will be monitoring for the rest of the training here. I will be monitoring the Aries channel on the Hyperledger Discord. And so please reach out if you have a question. The questions you ask there are great because they'll last past this training, and you can pull it back up and see what the answers were. Of course, we're welcome to ask questions here as well, particularly as it relates to something immediately on the slides or something specific to the presentation. Any general questions about Aries or any of the technologies that we're talking about might be better in the Discord chat channels. And so we're running just a little bit ahead of time. Lynn, are you ready to pick up with the next section?
Yep, I'm ready.
All right, we're going to pass it over to Lynn Bendixson.
Well, thanks, Sam. Sam was right. We are running a little bit ahead. Just a quick reminder, we have plenty of time for questions here. We kind of are expecting this to be interactive, and post your questions in the chat, and we can answer them as we go along here. Feel free to, if someone sees a question in the chat that I can answer during my part here, feel free to speak up. So I'm going to be moving a little bit more technical now. We've kind of been doing some high-level overview stuff, and with the Scott talking about identity and Sam talking about the community, I'm going to talk a little bit about the tools. It's still kind of baseline stuff where we're, not really in depth yet, and that'll be after I talk. There'll be a break for 15 minutes, and then we'll get more in depth after that. And there's an opportunity to kind of do some hands-on stuff during my part here, but I won't be specifically doing that. if you want to bring up your Indy CLI, you'll be able to type in some of the commands as I show them and talk about them, but we won't be taking a lot of time out to do that. If you want to do some more hands-on Indy CLI stuff, since we're kind of ahead, we might have time at the end of the presentation, the formal presentation, to go over some more of that for those that have more in-depth questions. So I am Lynn Bendixson, the Director of Network Operations at Indicio. I've been working with Hyperledger Indy networks for about 4.5 years now. So I'm one of the experts in the community on that. You can see my email address here. Feel free to send me an email with any questions, and then on Discord and GitHub and a few other community type places you can reach me at Lynn Bendixson. Also, Sam mentioned that there's a Trust over IP as one of the groups that you can get involved with. I've been asked to be a co-chair of the Utility Foundry Working Group. That work group kind of tracks public utilities or Hyperledger Indy networks, and we write papers to help people to build those. So that's kind of where I hope to contribute. Where we're going to start for the tools part here today is with the indyscan tool. And again, we're just going to quickly go over this. If you have more in-depth questions about it, feel free to ask. This is just kind of to let you know that there's a tool out there available for you to use. The tools that I will be sharing today are the Indicio, specific Indicio implementations of the tools. Other networks have also implemented these same tools, and you can refer to those for the network that you're most interested in. But we'll just skip over here to the indyscan tool and show you that you can select your network across the top here, whichever Indicio network you want to look at. And then down below, it shows the main subledgers, I like to call them. The domain transactions, or the NIMs and the schemas and the credential definitions all go onto that ledger. The pool transactions are just adding and subtracting nodes from the ledger. The config transactions are the auth rules. So most of what you'll be looking at as a developer, this is kind of a developer tool. You'll be looking at the domain transactions and trying to see, what it looked like when you tried to write your transaction to the ledger. And to get more details on that, you can click up here on the thing that says domain, and then you can search for the kind of transaction that you just wrote. I just clicked on NIM up here to highlight that one, and so now it shows all NIM transactions. You could highlight your DID and put that into the search thing here and search for your just your DID and whatever NIMs your DID has written to the ledger, etc. So that's pretty much the indyscan tool, and a little introduction as to what you can do as a developer to use that tool to see how things are going with your code that you're writing to try and write to a ledger. And I forgot to mention that was written by Patrick Stoss. He donated that to the community several years ago, and I just took his code and made a few config changes to make it work for Indicio. Okay, before we get into the next tool, let me give you a little bit of background on the roles that exist on a Hyperledger Indy network. There used to be kind of a hierarchy of roles where, the trustee was at the top and he could do everything, and it kind of went down from there, but that's not the case anymore. Each role kind of has its own separate things that it does. There's not really a big role that can do, oh, sorry about that, that can do everything. So essentially, we're just going to talk about some of the roles here. The ones that we care the most about are a trustee, for this training today anyway. Trustee is the one that writes admin transactions to the ledger, and they also have the privilege to write endorser DIDs to the ledger. So when an endorser joins a ledger, it has to have the approval of the trustee. And the endorser, the thing that they can do is they can write credential transactions to the ledger. They write schemas, credential definitions. They can also write author NIMs to the ledger, or author DIDs, to help with the making it so that the authors can send their transactions to the ledgers. The authors create transactions, as it says here, and then they can issue credentials from that created transaction that they built, but they have to have an endorser sign their transaction before it can be sent to the ledger. And then we mentioned here too that there's a transaction author agreement that must be agreed to before any of these roles write to a ledger. And most
and then yep. we had a good question in chat that I just wanted to raise. What is an example of an administrative transaction that a trustee might engage in?
Good question. So one example is adding a node to a ledger. Ledgers start off with a certain number of nodes, and then as node operators join the group, they need to be added and removed. And that's one thing that a trustee can do. Trustees can also add other trustees to the ledger. And so that's kind of what we mean by an administrative transaction. Anything to do with the running of the network, so to speak. They can also add auth rules, etc. Does that answer the question?
I think that sounds great. Thanks, Lynn.
Awesome. Okay. See if I can move this chat somewhere where I can keep seeing that. There we go. Okay. The next tool I want to introduce is one that I think that Daniel and Shar will talk a little bit more about later, about the actual place where you would use this tool during our hands-on portion of our Aries stuff today. The SelfServe tool is for demonstration or test networks to help to add an endorser, or it says a privileged NIM here, but essentially an endorser to the test network. So I took a tool that someone else had written and made a few changes to it, and it's kind of a community tool now where others have made some great changes to it as well. But this helps to test things out before you get to production. The production networks will regularly require fees and other things to be able to get an endorser DID on them. But for the test nets, it's all free for most test nets. So at least for a certain period of time. And so this is the tool. Essentially, all you'd have to do is put the network in, and then a DID and a ver key. And you can create that DID and ver key in a number of different ways. We're not going to go into those details here. And there's some instructions here at the bottom, a link to some instructions to help you figure that out. But you just put your DID and ver key in here and click submit, and it puts, there's a wallet on the back end of this. It has the permissions to be able to write your DID to the network as an endorser NIM. So that's what the SelfServe tool is to get it so you can do stuff on the network, essentially. So another tool is the Indy CLI. This is a command line tool for managing local wallets and DIDs and other things. There's other tools that do this. This is kind of a baseline tool that can be used to do some of those things. in view and manage networks. It's kind of an administrative tool. I use it most when I'm watching my networks or creating a new DID. But the creating a new DID can happen in the Aries toolbox that Daniel Shargan introduced as well. So as a network admin, I do things just a little bit differently, but there's a little bit of intro to Indy CLI during the rest of the presentation. We probably won't be using the Indy CLI. It'll be different tools. And so I'm just going to show you this really quick. This is a part where you can try these commands if you want to. And if you've gone through the workshop prerequisites, it had you install these things. Install the Indy CLI so you could try it out. And we'll leave that to you to do either during the break or at another time. But essentially, when you get started, it kind of goes in an order here. You need to create a pool, and essentially, you're not really creating a pool. The pool really represents the network. You're creating a pool handle. So just so it's for clarity here. So you create a pool handle based on a Genesis file. That's what we're showing here. And then you connect to that pool that you just created. And then you create a wallet. A wallet holds all of your keys, and it holds your DIDs and other things. You can create multiple wallets. So I do that since I manage multiple networks. I create multiple wallets to manage the DIDs for each network to keep them organized and separate. So you just create a wallet and add a key. The key is just like a password to keep your wallet secure. And then you open your wallet, and then you can add a DID to it. Oh, sorry. The metadata part of this, if you just do DID new, it works. It creates a new DID, but then your DID is in your wallet. When you do a DID list, you just show it there and you don't know what it was for. The metadata helps to make it so when you do a DID list, you can see what each of your DIDs is in your wallet. And for a guy like me with 100 or so different DIDs that I use for different purposes, this is required. If you only have one or two, you might be able to remember it yourself. But this is sure useful to have a little text message that tells you what your DID is for when you create it. The DID, this does not put your DID on the ledger. This just adds it to the wallet. And then someone with privileges will need to add that DID to the ledger if you want to do some things on the ledger. And then to do things with that new DID on the ledger, you do a DID use, and you'll be able to do things on the ledger as soon as your DID has been added to it, and you do this DID use command. So that sets you up. This is kind of the setup. And then you can run a few commands. So I already mentioned listing things. You can do a pool list, a wall list, or a DID list to list those different things. Sorry, I touched my mouse funny. It switches on there. Sorry about that. The tab here shows some command hints and stuff. If you do a help, then it shows more details of helps. So you type in ledger and then hit tab, and it shows a bunch of stuff that you can do with the, starting with a ledger command. If you just type in help by itself, it shows the main commands, which is these ones here, pool, wallet, DID, and list. That's the help command up here. And then you can get specific help as it goes down, as you see here. And then if you want to go and check out something on the ledger, you can do a get nim or a get schema, get credit, those kinds of things. And in this case, since your nim wasn't put on the ledger yet, it would, if you ran this command, it would show that your DID is not yet on the ledger. And that is the end of my part of the presentation. Are there any questions at all about any of the tools or anything? Have we seen anything more in the chat where there's a question about tools and stuff that I can help with? Well, thanks a ton, everybody.
I came in late. I'm sorry. Will all this be shared in email or somehow?
the Hyperledger folks, last time we did this, they shared everything with all of the participants. So these slides will be available, and then there'll be a also the recording of this will be available in a couple of places.
Yeah, 100% correct, Lynn. We will send out an email to all the registrants with just basically follow-up links. And this is being streamed to YouTube, and it'll be on the Hyperledger YouTube channel, once it encodes. But yeah, we will send out a note to everybody with links and follow-up.
Thanks, Sean. Thanks, Lynn.
There's also a handout that is that I just put in the chat, which has links to all the sort of the relevant things for our workshop here today as well.
Well, thank you everybody so much for joining us today again, and we'll I think we're ready for a short break. Those of us who are running this will, some of us anyway, will likely be around during the break if you want to ask some questions, but it's straight up at the top of the hour. I believe we will return at 15 past the hour. We're going to have a 15-minute break here. Thanks again.
During the break, feel free to ask any questions about anything else related to Hyperledger as well. We have people on the call who can help.
So we should mention what this QR code is for. Maybe Daniel, you can say the right word. So what that's pointing at.
Daniel stepped out just quickly before he gets started next time. So I don't think Daniel's going to. This is the handout link, isn't it?
Handout, that's the right word. Thank you.
Yeah. So this is the handout link that we also pasted into the chat. So it's the same thing. And that will help, particularly in the next section with Daniel and Shar as they walk through Aries and how to make all that magic happen.
Matthias, I see your hand up.
Yeah, thank you so much. Thanks again to all the presenters. I'm learning a lot. One of the conceptual things that kind of struck me is, and it makes really sense, right? But that issuers can also be verifiers to give a holder access. So I'm thinking to the earlier example with Gmail and everything, right? Passwords and whatnot. So I'm thinking of issuing and verifying a DID for a holder to give access to a system. So I'm wondering if Indy or Aries or essentially a DID solution can be utilized to give temporary access, whether that be reading or writing, to Fabric. Actually, is there a for some more business logic?
So we've had some community meetups that have discussed the integration between Aries and Fabric. I think just the previous one, and I can find a link for that. You can absolutely do that. So it's worth noting just from a terminology perspective that we don't typically issue DIDs to individuals. They create their own. That's one of the inversions in decentralized identity that happens. But you can still verify via two different ways. One is you can verify DID ownership, and engaging in a Didcom protocol gives you that kind of by default because of the authenticated encryption that's used. But the other thing that can be useful is actually a credential. And so if you issue a credential of permission, if you will, then you can verify that on the other side, independent of what DID the other party has in particular. So there's a variety of approaches that you can use depending on the particular case that you've got. But that's absolutely a useful thing to do in order to authenticate or authorize folks that are participating in these various aspects of these systems. You mentioned Fabric, of course, but it can be applied in a variety of other ways as well.
Great, thank you.
Hey, Sam.
Yes.
This is SD Shaubratra from Instant. I have a couple of questions. One question is that right now the Aries stack, which actually created out of Indy to make it more independent and ledger agnostic, right? Do we have any other implementation other than Indy at this point?
Other than Indy of what now?
Ledger?
Yes. So, well, there's a variety. For example, there are DID methods that lean on Ethereum or on Bitcoin, for example, as a verifiable data registry for those. They don't all have the same features as Indy. Indy is relatively unique in what it provides. And so because it's purpose built for identity and doesn't have some of these other features, it doesn't do smart contracts, it doesn't do, there's not a financial transfer aspect of it like Bitcoin has, for example, then it's different than those. But there definitely are other ledgers or other sort of VDRs that you can have underneath the stack. Does that answer your question?
Yeah. I'm still trying to get my feet wet around all these terminologies and concepts, but yeah, understood.
Sure, there's a lot to learn, and we hope that what we have today can help a little bit anyway in the wide world of all of that. So we're grateful that you're here.
That's right. Thanks.
Lynn, go ahead.
Hey, this is Suma. I have a really bad throat. Sorry if I sound terrible. I'm trying to understand more about the anon cred separation and whether anon creds can today be implemented separate of Indy Aries, or if that's the direction we are going. So what's the timeline? I'd like to understand more about what's around that separation, what it means to the broader identity space.
Yes, so anon creds is a credential format that was initially developed, and it was tied specifically to Indy in the sense that you needed the assets involved to be written to an Indy ledger. The anon creds effort that's going on in the project is working to make that optional in the sense that you don't strictly need Indy. You can use other things underneath it besides Indy as a VDR. It's worth noting that you'll need to be prepared to provide a VDR that has a sufficient number of features in order to make it useful. Just because Indy is optional, Indy still turns out to be an excellent choice for anyone implementing anon creds. And so I don't want to convey the idea that you'll simply be able to walk away and not use anything underneath it in order to and get the same features that you would if you were basing it on top of an Indy ledger. So it's a little hard to predict the timeline, which was, I believe, was the main part of your question about how long that's going to take. The work has been underway for a little bit, and then has just recently moved into the Hyperledger umbrella as the anon creds project. And so those meetings are ongoing. It's a little hard to hazard a guess, but I'm assuming that at some point next year that spec will be more fixed. There are folks that have done implementations of anon creds that are separate. The Checked network is one of them that does that, but they did so sort of in a pre-standards way. The Checked folks are great. They're involved in the process, and they, to my knowledge, anticipate making any corrections necessary to their implementation to make it abide the future anon cred spec, of which isn't done yet, of course. So it's not going to be weeks. It'll be It'll be more in the timeline of months before that's ready, but that is a direction that it is going. I do though want to highlight, and there's not enough written about this. We're working on that to highlight the fact that even if you don't have to use Indy, Indy turns out to be a great answer in a very large number of cases, and so the use of non-creds without Indy is generally going to be useful when folks already have a ledger that could provide the same sort of features like immutability and high availability and attack resistance and things like that.
Gotcha. And you said that there are some minimum requirements for the verifiable data registry. Would I find that information in the Hyperledger site somewhere, or
you won't yet? So that's one of the pieces that hasn't yet been added to the in progress spec for non-creds.
Okay, gotcha.
But that will be coming.
And one question I've always had is non-creds W3C compliant?
So W3C, the W3C data model spec has opinions about how the data ought to be oriented. Part of the effort, the non-creds effort, is making standard a representation of a non-creds in the W3C compliant format.
Oh.
So a non-creds isn't yet today, mostly for historical reasons. A non-creds was a thing. The current version of a non-creds that's running has been a thing before the W3C data model was created.
Yeah.
But the next version of a non-creds, that's definitely a focus to include that ability.
Gotcha. Thanks a lot.
Yes. Okay, I'm going through the questions here.
I put the Indy Fabric meetup link in the chat for anybody that wants to see that. There's
excellent.
And
that was a community meetup that Indicio did, where we had some folks talk about an integration that they did. It may not perfectly answer your question about Fabric and Indy integration, but I thought it was definitely worth mentioning, given the combination of the two technologies. Thanks, Lynn, for grabbing that link. Daniel, and I apologize if I butcher anyone's name, is there a way to transfer somehow the holder right of a verifiable credential to another holder? So there's a couple of things you might mean by that. One is that, can I maliciously transfer that to another person? And I can't without revealing keys that would compromise all of the credentials that I held. So there's not. So there are protections in place that make it a severe disadvantage to do so. For high, I don't want to get too deep into this at this point, but there are methods for really high value credentials with liveness checks and sort of other links to things like that are not used typically needed in the general case, but can be useful for high value cases. If there's a legitimate way, meaning you want to be able to transfer a credential from one person to another person, the word typically used there is delegation. So you would delegate a credential to another, and then it's up to the verifier of the credential whether they accept that delegation or not. And so there's a handful of complicated bits in there. There are some policy ways of doing that and some cryptographic ways of doing that. But in general, the cryptographic or the verifiable credential community has not really standardized delegation in that way. So hopefully one of those two things were related to the question you were asking. Yep.
okay, we got 1 more minute left on break. Get yourself situated and get ready for the for the Aries part of our presentation. 1 minute left.
Hello. I don't know if I'm allowed to use the mic, but I have a question. If someone can answer that.
Yeah, go ahead and ask.
Yeah, because I raised my hands, so no one answered. I'm new here, and I really don't know like about the tools and stuff. But is it close to HTML that we use it at the background of websites? And is there any reference that I can start with to complete with you guys? Like I can like study or see it on YouTube to like I can complete with you and about the tools and these stuff.
There are pieces of the technology that have some similarities to HTML. One of them would be the credential formats themselves. There's some cryptographic things in there as well, but there's data formats that sort of separate that out. There's also communication protocols, and the one that we'll be using today is Didcom. And Didcom itself has messages that also have some similarity there. Most of these things are based on JSON, not HTML, so the JavaScript object notation. And so this is more of a way to communicate between systems rather than present stuff directly for user viewing the way HTML typically is. So it's a little different, but the next section, Daniel and Shar will be talking about tools that exist within the Aries ecosystem to help to get in started in some of these things. So hang on, and I think that they'll have what you're looking for in terms of ways to get started and understand what's going on. Thanks for asking the question. Sorry we didn't get your hand earlier. Bhaskar, your hand's up. We're having trouble hearing you. There's lots of background noise.
Yeah, I want to know about
I'm sorry, Bhaskar. I can't really discern what you're asking.
Hey, Bhaskar, put your question in chat. We can probably answer it from there.
Excellent. And Daniel, looks like you're about ready to keep going.
Indeed. Welcome back from intermission. We had a lot of great questions going on there. Please feel free to continue to put your questions in the chat, especially as we continue throughout our presentation today, and Sam will help to moderate those, raise them as needed, and redirect you to other resources if that's helpful. So we are going to come back together again. Another reminder, we have a handout accompanying our presentation. I've been posting the link religiously throughout this presentation. I'll post it yet again just now. So that handout includes useful links. It will include the commands that I'll be using to start up the agents that we'll be looking at here in a moment. It also links to the prerequisites that we sent out as part of the workshop. If you haven't had a chance to go through those prerequisites yet, but would like to try to get on top of those before we get into the hands-on portion later on. Yeah, so let's go ahead and jump into it. So we will be talking, of course, about Hyperledger Aries. I am Daniel Bloom. I am a software engineer at Indy, also a team lead, I guess I should mention that. You can reach me at daniel@indyco.tech. My GitHub handle is dbloom, and wherever I can get that handle, I use that on my social media, but it might not be the same across all of them. But yeah, definitely reach out over email if you need to contact me, or GitHub. That will work as well. I am a co-chair on the Diff Interop working group. I've also been a long-time contributor to the Hyperledger Aries project. Been around since even before the Hyperledger Aries project existed, as did several of the folks at the Indy tech team. So started off in the Indy agent working group, working on the Python reference agent, which eventually influenced at least the creation of the Aries Cloud Agent Python code base that we will be using today, and of which I am an active contributor and maintainer. Really enjoy working with the government of British Columbia to co-maintain that project with them. Yeah, excited to be with you today and to talk about Hyperledger Aries. And with that, I'll hand it off to Shar for a brief introduction of herself.
Thank you, Daniel. My name is Shar Howland, and I'm a software engineer at Indy CLI. There's my contact information as well. I'm an active contributor on the Aries Cloud Agent Python ecosystem, developing plugins and other purpose-built agents and protocols. I also co-chair the Identity Implementers Working Group and the Indy Contributors Working Group. I'll just take a brief moment to plug those and encourage you to join. The Indy Contributors Working Group is a great place to start getting involved. In the community, we take a high-level view and track progress across the different working groups in the community and the foundations that Sam mentioned earlier. We invite speakers each call to give a presentation on a relevant topic. And the Indy Contributors Call, of course, focuses on the Hyperledger Indy project that Lynn mentioned earlier. So please join us for those. I've got my Hyperledger mug here, so I'm all set. And I'm excited to be here today and talk about Hyperledger Aries.
Cool. So we've got a stacked set of on the agenda for today. We'll first start off with kind of a conceptual discussion of what's going on between Aries agents and the network, focusing on first identity agents, what even are they? Moving on to the agents and the specific tools that we'll be using for our demonstration today. Then getting into some of the details of the protocols and the messaging that's taking place in the background. And then the last portion of our meeting will be a hands-on with Aries Cloud Agent Python and the Aries Toolbox, where we'll use those to create connections between agents, issue credentials, and verify those credentials. So yet again, as another reminder, we have a handout for this. Really highly recommend taking a look if you haven't yet. There's some useful links as well as commands that we'll be using throughout our presentation. As a reminder on questions, Sam will be helping us to moderate questions during our walkthrough of our slides today, especially as we get into the hands-on portion. So please put your questions in the chat. I'll ask you to refrain from coming off mute while we're talking, just to help me keep my flow going a little bit, but Sam is more than welcome to interrupt us as needed, especially for highly pertinent questions to the presentation. I also encourage you to ask your questions in the Aries channel on Discord. We have Colton Wilkins from the Indicio team and others who are monitoring that channel. So if you have any deeper technical questions that you'd like to ask or are having technical difficulties, they are there to help out as they can. We even had last time the BC Gov team was getting involved in answering of questions, and it was a really good synergy that we had going on. So I highly recommend getting plugged in there on the Discord channels. We are, after all,
apologies, Daniel. In addition to the handout, I also put a link in for our prerequisites document that tells you how to get set up so that you can do the hands-on part of it. The Indy CLI setup in there is not required.
Thank you for that reminder. Yes, let's see. So Sam may actually redirect some of your questions to Discord. I bring that up just so you're not offended that the question isn't being answered live or anything. I think there are just some questions that live better in Discord. First of all, because it's excellent to get input from other members of the community, but it's also a public record of the questions and their answers. If you have a question, it's likely that somebody else has a very similar or the same question that you do. So sharing that question and answering process is helpful for the whole community. After all, we are a community and we'd love to have you join us on Discord. So with that, jumping in on our first conceptual topic here, which is agents. What even are agents? So agents are the pieces of software that we as humans use to help us interact in a decentralized identity world. I don't know about the rest of you, but I don't do too terribly with math, but the encryption and cryptography that are required to interact securely over the internet is just beyond my capabilities. So we use agents and other software to help us to accomplish these goals. So when we talk about agents, we generally mean identity agents within the context of Hyperledger Aries. The term agent is quite overloaded in the general tech space. So we are talking about identity agents specifically. These agents are, again, the software that helps us as individuals, as people, to interact in a decentralized identity world. And it will generally act on behalf of a single identity owner. And by identity owner, I mean either us as individuals, or it could be an organization, like a college or business or bank, whatever, even though there are multiple individuals with identities behind the organization. As a unified organization, they have the ability to issue and receive credentials that identify them. So an organization can be an identity owner. It's also possible for Internet of Things devices to be considered an identity owner. Anything that it makes sense to assign an identity, and these verifiable attributes can be represented by an identity agent. There's an excellent question in the chat that I just noticed. Is an agent a wallet? And that kind of leads into the next point here. So agents hold and use cryptographic keys to securely perform their responsibilities. So the term wallet, as we tend to use it, at least within the Hyperledger Aries space, refers to that component, the secure storage element backing your agent that helps us to keep our keys private and keep our verifiable credentials in a safe location. So in that sense, yes, an agent has a wallet, and we will often refer to, or sometimes, I guess, refer to agents as wallets, especially in the mobile wallet sense, when we have an application on your mobile phone that helps you achieve all these goals. But I would narrow the scope of the definition of wallet to that secure storage element. And then the agent layers on top of that secure storage all the other interactions that make the Didcom ecosystem a rich and secure and mutually authenticated mechanism for communication. The summary that Sumo put in the chat, I think, is a good one. The agent is active and the wallet is a more passive component. I think that's a fair representation. In fact, I thought that was Sam that was posting that comment. That's how on point it was for me in my view. So thank you for that input. Cool. So identity agents also interact with other agents through DID communication protocols. And we will get more into the details of Didcom and those protocols as we go throughout our presentation today. So when we talk about identity agents, we tend to have these terms that we use to categorize these agents. One you'll hear a lot today, for instance, is a cloud agent, since we are using the Aries Cloud Agent Python project. And the term cloud agent generally just refers to an agent in the cloud. It does not, strictly speaking, imply trust or the lack thereof, or imply that it will be one particular transport mechanism or another, or ownership. It's merely the location of the agent. So you could have a cloud agent that is owned by an individual, in which case it would be owned and pretty well trusted by the prototypical Alice. It could also be in the ownership of another party, and we rely on that cloud agent for various services, but we don't trust it quite as much as we would if we ourselves owned the agent. So the term cloud agent itself just denotes that it's something running in the quote-unquote cloud. In contrast to the cloud agent, we have an edge agent, which again is merely a denotation of the location of the agent, in this case at the edge, whatever that might mean to you. Could be a desktop computer, could be a laptop, could be a mobile phone, could be your tablet. These are just devices at the edge. Some other examples of agent categories that you might hear: mobile agent, workstation, server, embedded, browser, blockchain, as might be embodied by a smart contract, IoT, or mesh. And in theory, there could also be paper wallets, paper agents, but those would need to be accompanied by associated infrastructure to help us actually do communication. So there's a lot of different ways to categorize and group these agents together. Not all of these categories are mutually exclusive either. So keep that in mind as we continue to discuss agents today.
There's a couple of questions in chat. You might want to.
I've been hitting them relatively. The one that you might address now, Daniel, is there any definition or specific approach or good practice on how access to agent should be performed?
That is an excellent question. The most general advice I think that I can give on the spot for that would be to make it as close as possible to the individual, the identity owner, directly owning the agent and the hardware that it's running on. It's possible to have custodial devices, custodial agents, which are agents that are hosted on behalf of an identity owner by another party. And there are clever ways to make it possible so only the user at the edge has access to the data stored by that wallet. But it's a difficult balance to strike, I would say, and I'm not sure that we've seen a good example of that quite yet within the ecosystem. We have, of course, multi-tenancy within the context of ACPI, and I can talk a little bit more about that later. But yeah, generally, as close as possible to the specific identity owner.
Thanks.
Yep. Cool. So in addition to these categories of agents that we've described, we've also have varying levels of complexity associated with these agents. Not all agents are intended to handle exactly the same functions. So I'll start off on the least complex side of the spectrum with a static agent. And these are agents that have pre-configured, or in other words, static key configurations and endpoint configurations for a single connection. So using that static configuration, they have the ability to send a message or receive a message from exactly one other agent. These agents generally don't have the ability to change these configurations without the intervention of a user administrator or wherever the device is running. But these serve an important role in especially extending out to legacy systems. So you might have, for instance, a static agent that gets triggered by a webhook, whether that's from GitHub, Shopify, wherever webhooks are coming into your system. A static agent could be used to take that data received by the webhook and then bootstrap it into a Didcom context and deliver that to another agent. Another example of a static agent might be a cron job running on a server somewhere. If you just have a regular, update on statistics on, I don't know, number of verified credentials or something, and you want that to be emitted to another external agent, a static agent could serve that purpose. Layering on complexity from there, we have what you might term as a thin agent. This is an agent that looks very similar to a static agent, except that its single connection is updatable. You might be able to rotate keys or update endpoints as received from a Didcom protocol that updated those values within the agent. However, similar to the static agents, these are generally, again, very narrowly focused on a specific use case within the context of a single relationship, a single connection. Let's see if I can come up with a good example of that on the spot. Again, I think these fill a very similar niche to the static agents, but just if you need to be able to have a little bit of dynamic updating of these values. So where you could use a static agent, you could also be just as comfortable using a thin agent. The next layer up from there would be a thick agent. And I mean that in the unironic sense, I suppose. So this is multiple updatable connections held by a single agent. However, the use case for that agent remains narrow. The common example that you might see in the community of a thick agent is a mediator, which is an agent that assists agents at the edge who have inconsistent connectivity to the internet to receive messages in a consistent manner. So mediators have many connections. They're generally speaking, you could have a mediator that is only willing to talk to a single connection, but they have many connections and they're willing to mediate messages on behalf of all of these connections. You could conceive that a mediator would want to be able to issue and verify credentials. However, that's not usually something that a mediator agent takes on, so it tends to be a little bit more narrow in that sense. Let's see, layering on from there, we have what you might call a rich agent. And this actually ends up being the best descriptor, excuse me, for most of the agents that will be that we see in the Aries ecosystem. Aries Cloud Agent Python, Aries Framework JavaScript, Aries Framework Go, all of these are intended to be a rich agent. So they have many connections and they are designed and intended to fulfill many roles on behalf of a single identity owner. Yeah, in this case, the number of use cases that are intended to be met by a rich agent are numerous, and we'll discuss a little bit more how we use these rich agents as we go on throughout. So identity agents, while we have these categories and these terms to describe their complexity, there is not really a hard and fast definition of an agent or a category of an agent. These are just words that we use to help us describe the interoperability goals, especially of these agents. So we can say that if something is characterized as a cloud agent, we don't necessarily expect it to be able to run in a mobile context. Or if it's a cloud agent, we generally expect that we'll be able to directly post messages to it without the assistance of a third party to mediate those messages. So keeping that in mind, that helps us to better orient ourselves within the ecosystem of agents that is continuing to grow as the Hyperledger Aries ecosystem and the Didcom ecosystems mature and develop. All right, so that leads us into the specific agents that we will be using today. So we will be using the Aries Cloud Agent Python project, which, and I pulled this directly from the GitHub description for the project. It is a foundation for building decentralized identity applications and services running in a non-mobile environment. So again, coming back to that cloud agent category. This is the project that I end up contributing to most frequently in terms of standalone agent projects. And this is going to form the primary agents that we'll be interacting with throughout our hands-on portion. We also have the Aries Toolbox, which is, again, a tool for interacting with Aries agents, pulled directly from our GitHub description there. And these are just open source building blocks for developing your own custom software to issue, hold, and verify credentials. Yeah. I'll get into a little bit more detail on each of these projects in a moment. So Aries Cloud Agent Python is a server agent. It is intended for use on a server and therefore does not really have all the infrastructure or architecture that is generally fitting to running on a mobile device or in a browser. You might be able to kludge it. There are some very creative and inventive people out there that I'm sure could make it happen, but it's just generally not intended for that use case. And so you might find support for some of these more niche environments, I suppose, within the ACPI code base. Another project is likely more suitable for your needs in that case. ACPI being a excuse me, but ACPI being a server agent is designed for horizontal scalability. So being able to spin it up in a Kubernetes cluster and dynamically expand and shrink as demand on the agent grows and shrinks is an explicit goal of ACPI. ACPI is or has the ability to act as an issuer, verifier, and holder of both non-creds, as we've been discussing during the intermission especially, as well as W3C, verifiable credentials in JSON-LD format. Right now, our support for JSON-LD format is limited to those that are issued or received using ED 25519 and BBS Plus signatures. But support momentum on that side of the ecosystem is continuing to grow. For our presentation today, we'll be focusing on anonymous credentials. ACPI is also capable of using the revocation that comes bundled with a lot of the functionality of anon-creds. We won't be getting into the specifics of revocation today. That could be its whole other separate workshop, truthfully speaking. But yeah, it does have support for that. The support is quite mature. And if you are looking into revocation support for anonymous credentials, ACPI is an excellent option. ACPI also supports multi-tenancy, which, coming back a little bit to that question that was raised earlier, multi-tenancy is the ability for the same agent to host multiple wallets. This is useful, just for the sake of efficiency. We don't want to necessarily spin up an individual server for every organization that needs to be represented in an identity ecosystem. So using multi-tenancy, we can double up resources a little bit, still in a secure and privacy-preserving way. But again, that is a use case that is good in some circumstances and not ideal in others. So it's, again, a balance that takes place there. The Aries Toolbox, on the other hand, is a tool for interacting with Aries agents. So just any agent in particular that is able to speak Didcom, you can connect the Toolbox to it and start sending messages back and forth. So the Aries Toolbox is a development and testing tool. It is not generally intended as an end user product. We think it's great. We use it quite frequently at Indysio, especially for the purposes of training, debugging, and testing. But it is not geared towards an end user, which means that we have a bit of a guts exposed mentality to the interface. We want to give developers as much information as they need, as conveniently as possible. And so a lot of the debug values or the raw values of credentials, for instance, are visible to the user of the toolbox, which again is generally not something that I would encourage at the end user level. Once again, there are other projects and tools out there that are far more appropriate to that use case. And we'll discuss a couple of those briefly as we go along. The Aries Toolbox is built on top of Electron with Vue.js and Element UI. Should be a pretty comfortable environment to you if you are a JavaScript developer. We, again, try to keep this a relatively hackable project and welcome any contributions that you may have. The toolbox itself is actually an agent, which is something that I hope is not too hard to wrap our heads around. I'll come back to that point and describe in more detail a few times throughout our presentation to help clarify that distinction. But the toolbox is, again, itself an agent, and it matches the thick category of agent in the sense that it has multiple connections, but still has a pretty directed use case. It's intended to act as a UI for any agent that's running somewhere else that is generally headless. The toolbox has protocol implementations, just like any other agent, and these are encapsulated in their own components. They're generally quite modular, which enables us to dynamically determine which UI elements to show on the screen as the connected agent supports that feature or does not support a feature. and the protocols supported by the Toolbox are kind of split by a couple of different, let's see, there's a set of direct protocols, which are communications occurring directly between the Toolbox and the connected agent. And then there's indirect protocols, which is, in a sense, remote controlling or puppet stringing the connected agent to trigger interactions between that agent and another agent. And again, if there's any confusion here, I will hopefully continue to elucidate this particular problem as we go along. All right, so on the agent side, a quick comment. I'm seeing questions in the chat. If your questions are of a more technical nature, I highly recommend taking those to Discord, where Colton can assist as much as he is able on those questions. And we will get to a point where we will be doing this directly as well in this demonstration. So if you want to follow along as I pull up agents and stuff, that could be helpful to your technical questions. So that'll happen in just a moment. Okay, so I wanted to briefly cover a high-level description of the architecture of an agent. I've purposely layered things out here in such a way that it looks familiar to those of you who are familiar with web server development. And I'll kind of layer on top of this and draw some analogies here. So first and foremost, we have the transport of an agent. This is how the agent actually receives and sends messages with other agents. Since that is, by definition, a significant portion of the responsibilities of agents, the transport and which transports you support are an important consideration when you're building out your identity solution. So just like a web server, where it receives requests over HTTP, an agent also receives messages over a transport, could be HTTP, could be another. After being received on the transport, we conceptually have this middleware, which reads the bytes off the transport, adds context to it, and then sends it off to a handler for processing. In a very similar vein, agents will receive bytes off the transport. Those bytes are encrypted. So we first need to pass those bytes into our middleware, which handles decrypting the message. Then the message might be a part of an existing exchange of messages, in which case the context of the message needs to be populated with the state of the protocol. And then that message is handed off to a handler in order for the next step in the protocol exchange to be engaged in. So we kind of have a flow through our software that looks something like this. Again, quite conceptually similar to a web server. So if that helps you to visualize what's going on, it's a good way to do it, I think. All right, so Acopi, while containing those basic components that we just discussed, also has a number of other components which help us to control it and extend functionality, interact with the ledger and other agents. So we, of course, have that transport and our handlers for messages. But in addition to that, Acopi exposes an admin API interface, which enables a controller component to exist in the ecosystem. And the controller is responsible for all the application business logic of the agent. The Didcom protocol exchanges themselves are a very discrete and stateful interaction taking place between agents. We don't want to mix in business logic into that process. However, it is, of course, necessary to have some control of the business logic at some layer of the stack. We need something that says what values go in the credentials that get issued to these other agents. And that's where the controller comes into play. It can also help you control under what conditions credentials are issued, help you navigate governance frameworks, and so on. So the admin API provided by Aries Cloud Agent Python is, again, an HTTP generally JSON body-based admin API. It's a RESTful interface. So you can write your controller in whatever software stack of your choice. Generally, whatever fits your needs best. It's also, I guess, important to acknowledge that it's not a one-directional communication between the controller and the admin API. The Accompy agent will also send webhooks back to the controller to inform it of asynchronous events taking place on the agent. So this is how we trigger the next step in an interaction, or based on the received inputs, have our business logic engage in the next business flow that is necessary for a given interaction. I see a question in the chat. Only with the controller we can name it as agent. That's a fair question. I would consider that's a hard one, actually. If you conceptually take the controller as the controller of like when events take place and how the identity is represented by the agent, then I guess you could say that without the controller, we don't have necessarily a complete agent. However, it is possible to have an agent that is, it just automatically responds in a given way based on, static criteria. But then I think in that case, there's an argument that the static configuration for that agent is the quote unquote controller. Controller is a common paradigm that we see throughout the agent ecosystem, but it's not the only way to do it. So I wouldn't get too hung up on whether the inclusion or exclusion of a controller makes an agent. As long as the agent is helping us to represent the identity owner and exchanging Didcom messages. As an example of something else that could or could not be considered a controller, a mobile agent has a UI that sits directly on top of it. And that UI is controlled directly by the user. So you could call the UI the controller of that agent. But again, I'm not sure that that's strictly speaking, a term that is particularly common in that sense. Good question, though. So in addition to the controller and the admin API, we also have a plugin interface. We'll be taking advantage of that plugin interface today. I'll get a little bit more to that in a moment. But then, of course, Accompy interacts with agents over the internet. So we again, use that transport to send and receive messages from these other agents. And then Accompy will also interact with distributed ledgers, especially to anchor public DIDs so that it can issue credentials to holders. Or verify those credentials, I should call out explicitly. So this is a bit of a reiteration of our conceptual discussion that we had a moment ago about the responsibilities of an agent. But Accompy, again, is responsible for securely storing the secrets in the agent, such as the keys associated with our DIDs, the keys associated with our credential definitions and our verifiable credentials themselves. It also holds those other cryptographic values crucial to helping us in an anonymous credentials ecosystem prove non-revocation and that disparate credentials were received by the same individual and so on. So these are all responsibilities of the agent and all functionalities that the Accompy agent has. Then it connects with other agents and interacts with distributed ledgers, which I already said. So Accompy has an increasingly mature plugin system. This is something that I've been really involved in from the start, so I'm quite proud of this fact. The plugin system enables us to do things like plug in a protocol implementation. We have a generally standardized set of protocols that Accompy supports, and it's got a very batteries included mindset, so it's possible that you won't need any plugged in protocol implementations. Very possible, in fact. But having the ability to bootstrap your own custom protocol for a use case or model out a a protocol before pursuing standardization of that protocol, if you so choose. That's something that we can accomplish with plugins. And it's something that we've had opportunity to do at IndyCO quite regularly to help us meet new and interesting use cases for our clients. In addition to protocol implementations, we can also tack on additional admin API endpoints. Often these might be associated with these additional protocol implementations in order to trigger the messages being sent or whatever actions are necessary to proceed with the protocol. It could also just be adding functionality to Accupy, just period. For instance, Accupy might not right now support just directly signing an arbitrary message string with a key associated with a DID. If you wanted to expose that as an API, admin API available to the controller, you could write a plugin that took care of that for you. You can also add custom event handlers within a plugin. Again, closely related with the protocol implementations and the admin API endpoints. But Accupy has an event bus, which fires key events as triggered by other protocols, other exchanges taking place. And if we wanted to tack on some additional functionality, you could, for instance, have a monitoring plugin which had some basic statistics that it was monitoring, like how many credentials have been issued or what have you. That could be a plugin that's just listening to events and then just pushing to your logging system. And that could be modeled as a plugin. Additionally, we have an ecosystem of DID resolvers. These are components that help us to resolve metadata about DIDs and the DID documents, which contain keys, service endpoints, things that are critical for us to be able to communicate over Didcom, but also critical for being able to verify credentials of the W3C JSON LD variety, especially. It's also possible to plug in separate message queuing systems. So Accupy by default has HTTP transports. You can also use a Redis or a Kafka queuing system. There are plugins available for either of those, which can help you tailor your horizontally scaled Accupy cluster to your needs, or to integrate it better with your already existing infrastructure. So yeah, Accupy plugins, highly recommend the functionality. Again, really proud of this system within Accupy. We will be using this plugin system today for the indirect protocol implementation that we mentioned as part of the toolbox. And this indirect protocol implementation allows us to remotely control Aries Cloud Agent Python through the Toolbox UI. Let's see. So for our setup today, this is generally what it will look like. And I'll again continue to point out what is what as we go through our hands-on demonstration. But we have the Aries Toolbox. This is the UI that we'll be looking at. And then we will have an Accupy agent with the Toolbox plugin installed. And this is what will be remote controlled by the Aries Toolbox. And we'll have two instances of this full setup, one for Alice and one for Bob. And we'll have two different Aries Toolbox windows, which represent our view into Alice and our view into Bob. So these are just a couple of the projects within the Hyperledger Aries project. There are many other agents and frameworks and other tools available underneath the Hyperledger Aries umbrella, as well as, of course, within the other Hyperledger projects. But I wanted to call out a few of them here, just so you're aware of the others, the big players. I say that casually, I guess, but it's, whatever meets your needs is the big player for you, of course. So first of all, the Aries Framework JavaScript project. So this is a very similar project to Accupy. There's a lot of shared thought space in that sense. It's merely just an implementation within JavaScript. They have slightly different approaches, and it's a TypeScript project. So if strong typing is your thing, Aries Framework JavaScript is definitely for you. But it also serves as the base for another project within the ecosystem, which is Aries Bifold. And this is kind of right now the open source mobile agent implementation. It's been around for a while now, and it's continuing to gain momentum. We use it quite heavily at Indysio. I think there's a team at the government of British Columbia that's also really involved in the development of Bifold, and there are many other players who are actively working on Bifold as a mobile agent implementation. There is also Aries Framework Go, which is a Go native Aries framework. Aries Framework Go, just to briefly call out, if you go and you look at ACPI, and then you go and you look at AFJ, and then you go and look at AFGO, you'll notice that there's a bit of a different approach taken within Aries Framework Go. There's not a better approach one way or the other. They've just chosen to go with a more Go native approach. So all of their components up and down the stack are written directly in Go, which could be a huge benefit for you. You might be interested in using some of the shared libraries, such as Aries Ascar, which I'll talk about in a moment. But it is a very mature and very well supported Go alternative for data communication using an Aries framework. Also notable is the Aries framework.net. So if you're in the .NET ecosystem, there's code out there for you as well. And the Aries framework.net, I'll call out, is much more in a similar vein to the Aries framework JavaScript and ACPI, taking advantage of some shared libraries as opposed to going hardcore, full stack, everything .NET or anything like that. Another critical project to make you aware of within the Aries ecosystem is the Aries Agent Test Harness. And this is a code base that enables us to validate the compatibility of our protocol implementations across these different frameworks. So the Aries Agent Test Harness can spin up ACPI and spin up an Aries Framework JavaScript agent, and then using back channels that have been developed for this purpose, trigger interactions between ACPI and AFJ, observe the results, and see if it met the expected end criteria. This helps us to construct a compatibility matrix between all the different agents and frameworks, as well as determining the compatibility of specific protocols between these different frameworks. It's a really valuable tool for helping us to validate that we are all on the same page as a community. And the results of those tests are run regularly, and there's a website where you can view the results of those regular runs. I don't have that, unfortunately, offhand. I might be able to grab that or see if one of the other Indysio staff could grab that if they happen to be aware of where that is. Let's see, other Aries agents and services. We have the static agent Python. This is a library that's intended for developing static agents, as I described previously. I have to plug this one because I'm actually the core maintainer on that project. It's a good code base. I highly recommend it. If a static agent fits your needs, go for it. And then we also have an Aries mediator service. This is actually ACPI, but bundled with additional infrastructure and quick start setup scripts to help you getting to a point where you can use ACPI as a mediator for use with your mobile agents. This will include like a starter controller, which you can then customize to your needs for your mediator service. And then we also have Aries Ascar, which I'm kind of using to represent a wider category of projects within the Aries ecosystem. We have shared libraries that we depend on to do some critical pieces of the agent stack. Aries Ascar, for instance, is a secure storage implementation, which is used by ACPI, will be used by AFJ in the near future. Yeah, and is just generally helpful for having a clean, well-vetted interface for pluggable storage. It supports multiple backends, so if you are running in a mobile context, for instance, you're not going to have a remote Postgres database that you're connecting to, generally speaking. You would rather probably prefer having a local SQLite database, which Aries ASCII makes possible to use either one. It's also possible to support other databases, but I believe the only databases currently directly supported by ASCII are SQLite and Postgres. You'll also see throughout several of these Aries projects, the Indy SDK mentioned. We are in the process of phasing out usage of the Indy SDK within the Aries stack in favor of Aries ASCII and a couple of other shared components. And the Hyperledger Anon-Creds project kind of plays into that as well. Okay, then finally, one other code base to call out here, one other project, I should say, is the Hyperledger Aries RFCs repository. An RFC, if you're unfamiliar, is a request for comments. And this is where actually a lot of the content for our workshop today was sourced. This is where we as a community gather to answer some of the difficult questions and then document some of those answers in a way that helps us to standardize across the ecosystem. This is where the Didcom v1 specification was incubated, and we'll get into more of those details in a moment, but it also serves as a really good knowledge base for developing your own agent or learning about the ecosystem of agents in Didcom in general. And with that, that concludes my portion of the conceptual stuff, and I will hand it off to Shar to talk about protocols and messaging.
Sorry, with all these windows, it took me a moment to find my mute button, but here we go. Thanks, Daniel. I'm about to talk about protocols and messaging. So we'll start with talking about Didcom. What is Didcom? Didcom is commonly, the long version is Did Communication. We will heretofore refer to it as Didcom. It is secure peer-to-peer messaging. Whereas verifiable credentials they contain information about the subject. Didcom is communication with the subject. And so why is this important? Didcom is the way for entities that use DIDs and verifiable credentials to communicate securely and privately. So Didcom provides the lower layer that enables other Aries protocols that we'll talk about in this workshop. It is the communication protocol used for sending and receiving credentials and presentations, but it can also be used for much more than verifiable credentials, including instant messaging, relationship-based user authentication, which refers to user authentication that uses verifiable credentials to verify the person logging in, as well as buying and selling. And so we will talk about some of the properties of Didcom. First, Didcom is secure. We know that we are actually talking to the person we think we are talking to online. This goes hand in hand with private. We know that we are only talking to that specific person on the end of the line. Nobody is listening in on that interaction. What makes Didcom unique in these respects is that it achieves this security and privacy without using some sort of third-party or centralized service to secure this communication. So it is decentralized. There's no centralized identity provider holding your information. Didcom is interoperable. This relates well with the decentralization piece. You are not locked into a specific app or operating system or blockchain in order to use Didcom. So it operates well between existing systems. Didcom is transport agnostic. It is not dependent on the transport to make sure that the message is secure and private. So Didcom can use HTTP, WebSockets, Bluetooth, email, even carrier pigeon as the running joke in the community goes. And Didcom is extensible. So you can add messages to existing protocols. You can even add additional protocols altogether. A few more properties worth mentioning. Didcom is message-oriented, and so it has one receiver or one sender and one or more receivers. And so when receiving a message, the receiver can decide to take or not take action in response. Didcom is asynchronous. It ensures that the receiver of the message is not required to respond in real time immediately. This is similar to email, where when you receive an email, you're not required by the technology to respond in real time. Thank goodness. Lastly, Didcom is routable. You can route a message through another party. So sending a message from A to B can be routed through C or as many intermediate steps as you want. However, any agents in between the sender and ultimate receiver cannot view the contents of the message. It is end-to-end encrypted. We often see this in the case of a mediator, which Daniel mentioned earlier, the agent that routes messages to another agent and can hold messages when that agent is offline. And so relating back to the transport agnostic property of Didcom, the transports can be different during different segments of the route. And I'd like to touch briefly on the interactions between these properties, between the transport security and interoperability properties. So the security of Didcom is not dependent on a given transport. The security is taken care of by the Didcom message itself and does not rely on the transports for security. However, transports and routing can augment security and usability. So for example, using HTTPS, many current agent implements can benefit from using perfect forward secrecy. This is a method that ensures that even in the event that a private key is compromised, an attacker could only decrypt messages information from that single session rather than the entire history. So it removes reliance on a single private key. And it is a long-term goal to implement perfect forward secrecy within Didcom itself. It's also important to note that requiring specific transports can damage interoperability. So even if you have a favorite transport that you like to use, requiring one means that your solutions can't integrate well with the rest of the system. And so people are encouraged to take advantage of technologies through protocols, using protocols rather than transports to make these interactions more efficient. So to step back just a bit and look at the big picture, we'll look at the layers of Didcom. So at the lowest layer, we have the transport. As we've said, this can be any transport. Moving one layer up, DIDs are very important to securing communications. In particular, peer DIDs are essential for Didcom. Peer DIDs are exchanged directly between parties and are not on the ledger, unlike public DIDs, which are published to the ledger. And so participants exchange DIDs and using the signing and encryption keys and service endpoint information resolved from their DID docs. This enables secure end-to-end communication. And so moving up to the top, we have Didcom protocols, which we will talk about now. So this is a phrase coined by Daniel Hardman. A Didcom protocol is a recipe for a stateful interaction. So this means that Didcom is essentially a state machine that provides definitions of states and the transitions between them. In addition to that, along with that state machine is the events and messages that cause transitions from one state to another. Many of the layers below Didcom have their own protocols, including TCP, HTTP, managing DIDs, Diffie-Hellman, etc. But Didcom protocols are different from those lower layer protocols. Didcom protocols build on top of those lower layers to define protocols with real-world social value. They allow you to do things like forming connections, requesting and issuing credentials, proving things, buying and selling, etc. So Didcom is sometimes compared to REST. So we'll take a minute to look more deeply at that comparison. REST stands for Representational State Transfer. Didcom is defined as message-based stateful interactions. REST uses a client-server model where there's a hierarchy between the server and the client. The server is generally considered to be the source of truth, and the client is dependent on the server. Whereas in Didcom, the participants in the exchange are peers by default with roles that are defined by a protocol. So in a particular scenario of a protocol, one particular participant might take on a role that means they are trusted to be the source of truth for that particular aspect, but at a basic level, Didcom doesn't have that same hierarchy. REST has the one request, one response system, whereas Didcom, you can exchange as many messages back and forth as necessary to complete the interaction. REST uses HTTP methods to indicate which action should be taken, whereas Didcom, as we've said, transport agnostic, so it could not be dependent on HTTP methods. The action is determined by message type. REST uses paths to indicate action. Didcom uses message types, which we'll talk about more, for an indication of what action should be taken. And finally, REST uses paths routed to handlers. Didcom uses message types to route to a specific handler for a message. So now we will get into ingredients for this recipe for stateful interaction. These are the components for a Didcom protocol. So we have, of course, the name and version. We have a unique URI that identifies the protocol, the message type name, which refers to the messages included in this protocol. We have roles that the sender and receiver can take on in the protocol. State and sequencing rules can be thought of as a state machine of how these messages and roles are expected to proceed. We have the events and constraints that provide trust and incentive. So, for example, maybe in this specific protocol, you require that parties have exchanged credentials to verify their organization. This gets more into the business logic side of things than the Didcom protocols themselves. The protocol that we are going to look at today to start off is basic message. This protocol is simpler than other Didcom protocols, so it's a great one to look at as an introductory example. And so we can look at what the components of this particular protocol are. So we have name, basic message, and version is 1.0. Version roughly follows the semantic versioning specification. Here we only include the major and minor version, though, those first two numbers, since the third number here is the patch, a version that does not impact the external API. And since Didcom can be thought of as an external API, we can leave it off. The URI is https didcom.org, basic message 1.0, so putting some of those pieces together. In this case, in terms of the message type names, there's only one message with the name message, a little bit confusing. We'll see how in other protocols, the message type name is not going to be message itself, and there can be more than one message type. The roles here are sender and receiver. There are no real state changes going on. The events are simply send or receive, and there are no constraints. So let's take a look at what this message looks like. We will look more closely at this type attribute. So type is a URI that resolves to documentation for this message, and it helps the receiver of the message identify what to do in response. So we'll take this apart and see where the different parts come from. The first part is the document URI. This serves as an identifier for the body that created or standardized the protocol. And here it's an official didcom.org protocol. The next part of the string is basic message. This is the protocol name. Then we have the protocol version, and then the message type name. Again, confusingly, message itself. Everything before this message type name is called the protocol identifier URI. And then as a whole, this string is referred to as the message type URI. Now that we've unpacked type, we can look at the other attributes in the message. The message type determines what attributes are expected to be present in the message. The ID is a universally unique identifier for the message. In basic message, we also expect to see a localization decorator, send time attribute, and a content attribute. So now we'll look at a more complex example from the issue credential v1 protocol. This is the offer credential message in particular. So we can recognize pieces of the type attribute. It has the same document URI of didcom.org. Issue credential is the protocol name. It's version 1.0, and then offer credential is the message type name. And then we can see the attributes expected for this message include comment, credential preview, offers attach. So that's a more complex example. So there are two layers of messages that work together to enable interoperable communication through DIDs. So those are agent messages. This is typically what is meant when we say message. And then the encryption envelope, which is also called the packed message. So agent messages are sent between identities to accomplish some shared goal. This could be establishing connections between identities, issuing and presenting verifiable credentials, instant messaging. The examples we've looked at so far of basic message and offer credential messages, those are agent messages. And then a packed message is a wrapper around an agent, enabling messages to be securely sealed while in transport from one agent to another. So you can see how this could easily be referred to as an envelope or encryption envelope. These use authenticated or anonymous encryption. Anonymous encryption would be where the sender is not able to be known by the receiver. That's only used in limited circumstances. We typically use authenticated encryption. Packed messages are end-to-end encrypted. As we have mentioned, even if a message is routed through one or more other agents on its way to the final destination, whatever agents in intermediate steps cannot access the contents of that message. All they see is the outside wrapper, the encrypted packed message. And this encryption envelope is a derivative of the JSON web encryption specification. There are ongoing efforts to further standardize this encryption envelope to better align with pre-existing standards. So back to our example agent message, we will see what it looks like to transform it into a packed message. So we will pass it along into a packed method that takes the plain text agent message as the message parameter, along with their verification key and my signing key. And so the verification key refers to the public key in an ED 25519 public-private key pair. The signing key is the private pair. And so from this operation results a packed message that looks something like this. Some of these values get really long, so we've cut them off for brevity. And so the ciphertext attribute is the encrypted agent message itself. The IV is an initial vector that is used in the encryption and decryption of the ciphertext. Protected is a base64 encoded JSON object containing headers for the packed message, and then tag ensures that the protected headers have not been altered between the sender and the receiver. So everything that we've been talking to regarding Didcom so far is about version 1. Version 2 was ratified this past summer, and adoption is rapidly advancing. It's important to note that most protocols work in both version 1 and version 2 contexts. A few require modifications, but mostly they are interchangeable. And so, again, they work fundamentally in the same way. That's why it's been relevant to still talk about V1, but V2 does have some significant improvements on V1 in that modifications have been made to allow it to be more widely applicable outside of the original Hyperledger Aries community where Didcom V1 originated. Just a few distinctions to call out. One is the message structure split between headers and body. These next two go hand in hand. The sender's DID is included in every message, and using those keys, you can resolve the key info. And so peer DIDs are now resolvable and contain the information that would have previously been included in a connections invitation. And so this means that the handling of peer DIDs and DID exchange are no longer needed. So we can look at a side-by-side of a Didcom V1 versus V2 message. This is an example of another protocol, the trust ping message. This is a standard way for agents to test connectivity, responsiveness, and security of a pairwise channel. So we can see that there is a from attribute in V2 that contains the sender's DID, and then we can also see that the body is split out. All right. So that was a lot of information on Didcom. That's the information that we have prepared. Before we move to a brief intermission, just wanted to, and we will next move into the demo portion of the workshop. But first, just wanted to see if there were questions that have come up.
Perhaps one question, Markus Spatz here. Is it possible to have agents, have these protocols mixed in environments? So you have Didcom 1 and Didcom 2. You have agents talking 1 and agents talking 2, and does that work in a joint environment?
I believe so, since most protocols work in both environments. But Sam, feel free to jump in with more nuance there.
It's correct. Didcom V2 was designed so that you can detect an inbound message, whether it's version 1 or version 2. So the Aries adoption of Didcom V2 is underway, and we expect most projects, all projects that I know of that are going on, will have a period where they accept both Didcom V1 and Didcom V2. Of course, after some period of transfer, then Didcom V1 will be deprecated, and Didcom V2 will remain in production.
Okay, thanks.
Yep.
It's an interesting question in the chat. What are best practices for storing DIDs as a holder? I think a lot of the same recommendations around storing keys, just private keys, apply as well to storing of DIDs and their private key material. Within the Hyperledger Aries ecosystem, we are fond of the usage of Aries ASCAR as a secure storage implementation. I should turn on my video, sorry. Which takes all the appropriate measures to zero out memory after a private key has been used and so on. However, there are, of course, other secure storage solutions out there. Indy SDK is still pretty widely used, and it even has a slightly more strict key interface that means that you're not even able to pull the private key material out of your own wallet. It is acting more as a software secure enclave is the term that's been used for it. We are in the process of phasing out Indy SDK though, but it's still definitely a valid mechanism for storing those secure values. I think we also see HSMs as a highly recommendable piece of hardware to be using in the future, especially for the cloud context where HSMs are already a frequent fixture of security in those contexts. The primary issue we have in that sense is that a lot of the protocols is an overloaded term. A lot of the cryptography that we're currently using has not yet bubbled all the way down to the HSM layer. There are some notable exceptions, and I'm aware of more than one effort within the community to enable HSM support within the context of Didcom and Aries more generally, and anonymous credentials. But yeah, best practices, store them as securely as possible. If you do not have experience in that area, highly recommend relying on a solution like Aries Ascar.
Another question that came up in the chat is a direct message, but I feel like it's worth, many people could benefit. It's a good question. So do we need blockchain to implement this? Didcom itself, I talked earlier about how we use peer DIDs to communicate. So it's peer-to-peer communications. Those DIDs are not going on the ledger. We are not interacting with the ledger when we are using Didcom. You'll see in the next sections when we get into the ways that we use verifiable credentials, that is where you do need blockchain, you do need certain information that is public on the ledger, but using peer DIDs through Didcom, you do not need blockchain to implement that.
Cool. I think now is a good point to officially have an intermission. Some of us will stick around, so if you'd like to continue asking questions in chat, please feel free. But let's plan on coming back at about 5 minutes. So maybe at the 35-minute mark.
That sounds great.
All right. Welcome back, everyone. Once again, hope you're able to stand up, stretch your legs for a moment as we get back into our hands-on portion. We're going to be doing a bit of a tag team between myself and Shar. I'll take us through some of the hands-on portions, and you can follow along at home for that. And then I'll pass it back to Shar to discuss a little bit more of what we just examined, or discussing the next portion that will be coming up. So I will go ahead and share some of my screen for that. Okay, real fast before I get into things, and I apologize for my repeated bringing up the handout. The handout is here. It is a good resource as we go along into this hands-on portion, especially. I'll be running these commands, and there's other useful resources linked here as well. Again, I will be doing my best to repeat the instructions as I go along. So the first time around, don't be too worried about making sure that you're following along at the right speed or anything like that. I'll go back and repeat the instructions. Let's see. Also, the presentation will be shared after the fact. So if you want to go through and check out the slides, we have actually included screenshots of all these steps on the slides. So you don't necessarily have to watch the whole video just to see what step we took on a certain interaction. So that will act as a resource for you as well after the fact. Let's see. I'm going to keep my browser there. Just let me get my windows arranged slightly. We are going to start off by getting the Aries toolbox running. So first we need to navigate to, open up a terminal, navigate to the directory where we have cloned down the Aries toolbox repository. In my case, this is in the Aries toolbox folder. That is likely different for you. And then let's do a few things just to make sure that we've got the most recent code available to us. So we'll start off with a quick git pull. If you're already up to date, excellent. If not, then we should be now. We can then do a quick npm install. I've already done that previously, so I won't run through and wait for this command again. But then after running the npm install, we can do an npm run dev, and that will bring up the Electron window after doing a few intermediate steps here. So let's wait for that to come up here in just a second. And here we are. And I've got some old connections to go clean up there. Okay, so after running the npm run dev, you should see a window pop up that looks something like this. If you have technical difficulties, I encourage you to reach out on the Discord channel for Aries, and we've got people standing by that can help you out as much as they can. No promises that they'll be able to figure everything out, but should be able to get you through some of the most common errors at least. And a shout out to Colton and Lynn and all those who are helping answer those questions in the chat. Cool. So now that we've got the toolbox window open, we are ready to open up another terminal window. I've got a separate one here for the Aries Cloud Agent Python agents that we'll be pulling up to accompany our toolbox instance here. So first we start off by changing directory into the location where you've cloned the ACPy plugin toolbox repo. Again, this is likely to be different from my location, but this is where I've got it. Inside of this folder, there's going to be a demo folder. We need to change directory into that. And then from here, we are ready for our next command, which is pulling up the Docker Compose. In my case, on my machine, I have to use sudo. Good chance you don't need to use that depending on your environment, but I will be including it here. So we do docker compose -f, which allows us to specify the file that we'll be running. In this case, we are doing the docker-compose.alice-bob.yaml file. And then we'll do an up --build on the end of that. Again, these commands are inside of the handout if you would rather just copy paste those values. All right, we'll give that just a second to pull up. If you're running this for the first time, you will have to wait through an image build for the Toolbox image. Shouldn't take too long. And then before long, you should see several containers started up here and some really large QR codes. These are convenient if you're connecting to a mobile agent, for instance, through an automatically generated connections invitation. We use this quite regularly when we're testing out Aries bifold, for example. There's also other ways to get a QR code representation of our invitation URLs. So I'll take us through, excuse me, a quick explainer on the containers that we're looking at here. We see an agent Alice and an agent Bob, and these are the actual ACPI containers, the ones that are critically performing the functions of an agent. We also have a couple of tunnel agents. These are just a supporting feature for this Docker Compose script. By including the tunnels, we make it really easy for us to be able to connect from a mobile agent, which isn't going to be on the same machine, and it's certainly not going to be within the same Docker networking namespace. So by including the tunnels, we are able to connect to external devices and can even connect across the internet. So that is something to bear in mind. This is opening a tunnel to a container on your local machine. There's also a local Docker Compose variant that allows you to skip that part if you prefer to do that. Okay. There's also a tail server included in here. That is a piece of infrastructure that you need in order to do a non-creds revocation. We will not be doing that today, but this config has all the pieces that you need in order to do that. Okay, so now that we've got our agents started up, we are going to connect our agents to the Aries toolbox. So before the giant QR codes, there is a line that should look like this. It says invitation URL connections protocol. We are going to copy that URL and paste it into our toolbox window under where it says new agent connection. Paste that in and then hit connect. We'll see a little bit of output from whichever agent we copy pasted first, which indicates that the toolbox and the agent are now connected. And then we should see a little card pop up for Alice. We now need to repeat that step with Bob here. So I'll copy that, paste into the new agent connection, hit connect. And now we see both Alice and Bob admin connections available to us within the toolbox. For the rest of our hands-on portion, we'll be using the toolbox windows that are opened by clicking the open text underneath each of these agent cards. And I'll try to arrange my windows in such a way that you can see some of the values at the same time, at least. Make that a little bigger. Okay, so these are our Alice and Bob windows. And as we were discussing earlier, these are more or less a window into the agents that are running within the Docker containers. ACPI doesn't generally provide a UI on top of the agent. That is something that we are providing from the toolbox in order to help us click around the interface a little bit more easily and be able to go through these sometimes quite complex interactions with minimal headache. ACPI does include the admin API, as we discussed, and if you navigate to the admin port for ACPI, you can see a quite convenient Swagger UI, which gives us the raw admin API endpoints. You can complete all the same operations that I'm doing with the toolbox here in that UI using the REST API of the admin API. Takes a lot more copying and pasting and know-how in order to do that. So we like to use the toolbox for demonstration purposes. So you don't have to worry about all of that. But yeah, there's no reason you couldn't recreate the same UI using the REST interface, we just find it quite useful and convenient to be able to do it through a Didcom interface provided by the Akamai plugin Toolbox. So these are the windows that we will be using. Let's take you through a brief walkthrough of the UI, just so you can have a little bit better orientation before we move on to the next steps. So first, the nav menu on the left. This is where we access most of the functionality here. So this first section where it says Toolbox to Agent, these represent the direct protocol implementations that we referenced earlier. These are interactions that take place directly between the Toolbox and, in this case, the Alice agent. In this window, it'll be directly between the Toolbox and the Bob agent. So if we click on Discover Features, for instance, what's actually taken place here is that the Toolbox has sent a Didcom message called the Feature Discovery Query message, which is asking the agent to report the protocols that it supports. So we see there's a couple of legacy iterations of these protocols, but we also see the didcom.org version of those protocol identifiers. So by looking at this list, we can see that the connected agent supports Coordinate Mediation 1.0. It also supports the introduction service, also supports Discover Features 2.0, routing, issue credential 2. It's a comprehensive list of all the features that are implemented by Akamai, where you will see repeats between the legacy protocol identifier and the current protocol identifier. These are representing the same protocol implementation, however. Another key point to call out here is that we also see this GitHub Hyperledger Aries Toolbox Docs Admin Basic Message protocol. So in contrast to these didcom.org ones, these are not an official didcom.org protocol. They could be, but they're not currently. So the documentation and therefore the document URI points to where you can find docs for these messages within the GitHub repo for the Aries Toolbox. So the Aries Toolbox defines these protocols that allow us to remote control agents that are connected to it. So the admin basic message allows us to control the basic message functionality. The admin routing allows us to control the routing. Admin transaction author agreement allows us to do stuff with the transaction author agreement, and so on. All right, so there is that. That's the Discover Features. We also have the ability to send a basic message directly to the agent from the Toolbox. This is really quite helpful. Often when you're creating an agent for the first time, basic message is the first protocol that you might implement just because it's basic and easy. So this is a useful way for us to trigger a message being sent to an agent and see if it was able to be correctly decrypted on the other side. If I did this here now, it will trigger a somewhat confusing interaction that I'll explain a little bit more later on, so I won't go into the details of that. But this is us sending a message directly to the agent. We also have a compose window, which allows us to manually construct or copy paste in the plain text of an agent message to be sent to the message in the background, or to the agent in the background, sorry. This is actually arguably one of the most useful features of the Toolbox, in my opinion. All these functions are great and help us do things quicker, but this is one that's like very unique to the Toolbox. We actually have the ability to directly construct a message and send it with the proper encryption and all that stuff to the agent in the background. Since Didcom operates at this, generally at the agent message level, but then must be in transport encrypted, it can be difficult to get to that encryption step quickly. So the Toolbox is a vehicle for us to be able to worry about the plain text of the agent message without needing to worry about converting it to the correct encrypted envelope to be sent off to the agent. And then included in this compose window, we see the 5 most recent messages that were sent and received by the Toolbox. So we can see that there was a basic message, new message that was received recently. I'm going to go ahead and trigger this trust ping message, which was automatically populated in the compose window just as a quick message. and we see that a ping was sent and a ping response was received back from the agent. So this was sent by the toolbox. This was received from the agent in the background. And then we can also view the full message history here if we choose. And this more gives you a view of the internals to how the toolbox and the agent are interacting, as opposed to what's going on between Alice and Bob, as we will go on to connect and trigger some interactions there. So this is just between the toolbox and the agent. By analyzing these messages, we can get a sense for what messages are being exchanged between Alice and Bob, but we do not have a direct log of those here. That's a feature that would be good to add. We still haven't gotten to that point yet with the toolbox. Yeah, so that's a quick walkthrough of the toolbox UI. Just as a quick review, if you are on the connection step still, you can copy these URLs, paste them into the new agent connection box and hit connect, and that should get you these little cards here that represent Alice and Bob, and then clicking the open text will open up these windows that I'm using here. And with that, I'll pass it back to Shar for our next steps.
Great. Thank you, Daniel. So now that we have started up the toolbox and the agents, we can move on to connecting them. I'll talk about what's going on in the background and then pass it back to Daniel for the live demo. So we will start with forming a connection between our agents, Alice and Bob. Alice and Bob both have their edge agents, their mobile devices, and then their mediator agents that are acting on their behalf. We've mentioned mediators a few times before. In this example scenario where Alice and Bob are using mobile agents, a mediator actually is required for them to receive messages, since the edge agent itself will not have an endpoint. And we're also dividing between Alice's domain versus Bob's domain. What we mean by domain here is that these are the devices owned by and under the control of Alice versus Bob. And so for simplicity, we can abstract away the multiple agents in each domain and just consider Alice and Bob. So here, Alice is going to create an invitation. As Daniel said, this can be a QR code, an invitation URL. This invitation is out of band, which means that it's not communicated directly through Didcom, because that connection channel has not yet been established. This invitation that Alice sends to Bob has an initial connection key, endpoint info, routing keys, and a label. So the initial connection key is used exactly once, just for sending that connection request message back after receiving this invitation. The endpoint information and routing keys are sent to make sure that that Bob can send a message back to Alice. The label is who Alice says she is. This is not a verifiable attribute, more of a suggestion and a convenient way to identify this invitation. We can't absolutely trust it, and identity verification should happen after the connection is formed. And so here's what this invitation looks like as an agent message. We might recognize some of these pieces from earlier. The message type URI shows that this is an invitation message within the connections v1 protocol. And then it has that information that I mentioned, the label, keys, service endpoint. And so after Bob receives this invitation, if he wants to connect with Alice, he sends a connection request message back to Alice's agent. The language here might seem a little bit unusual, that Alice sent the invitation and Bob is sending a request to connect. In response, it's important to note that they are peers in this interaction and there are no imposed requirements. So Alice can send an invitation to connect with Bob and give information on how to reach her, but Bob can choose to send or not send a request to actually connect with Alice. So it's a request to elevate the invitation to the level of a connection. And depending on how the agents are configured, these steps can be automatically accepted. So it might feel more like a simple interaction of accepting an invitation, now you're connected. But even if it's automated, this is what's going on in the background. And so this connection request contains label, similarly the suggestion of identity, Bob's did, which he will use in the future to secure his communications with Alice, and his did document, or did doc for short, which contains relationship keys, routing keys, service endpoints, all the cryptographic information required to secure future communications and allow Bob to receive messages from Alice. Here is what the agent message of the connection request looks like. And here we see that it includes the did and did doc. Now, Alice sends that information from her side back in a connection response message. So this includes Alice's did, which Alice will use in identifying her future communications with Bob, and Alice's did doc, which will allow them to communicate securely and allow Alice to receive messages from Bob. So this is what the connection response agent message looks like. There are additional identifiers to make sure that Bob can correlate the request he sent out with this response. And the connection data that Alice sent to Bob is signed using the key Alice used in the initial invitation. So Bob knows that this response came from the original creator of the invitation. So now that the dids and did docs have been exchanged, this connection is established. And a quick note on forming connections using Didcom. As we talked about before, these are peer-to-peer connections, but they are not necessarily direct. We can use a third party like a mediator. Whatever third party, again, cannot see the contents of that message because it is end-to-end encrypted between Alice and Bob. The connection is not a transport layer connection like socket or open HTTP requests, et cetera. It is a Didcom connection. And then the agents are connected and the interaction is considered complete when Alice and Bob have exchanged dids, keys, and service endpoints, that information held in the did doc for future communication. And so now that we've looked at what's happening in the background, in forming a connection, I will pass it over to Daniel to show what that actually looks like using the toolbox.
Indeed. All right, so up to this point, we've talked about the direct protocol implementations, the discover features and these over here. And we have not yet touched the agent-to-agent interactions. So once again, this is the toolbox telling Alice, the remote agent, to do something with another agent potentially, or to trigger some other action directly on the agent. So we will start off by taking a look at the invitations tab here on the left. So the invitations tab allows us to create a new invitation, which should hopefully be pretty self-explanatory. There is a perhaps rather complicated looking form here. A lot of these values are of interest primarily to developers and those who are working on agents. For our purposes today, we do not actually need to modify any of these values, so the default values of the form are perfectly acceptable. But we do have the ability to instruct the agent to assign an alias to the connection in terms of our internal representation of this connection, so we can easily identify it later. We can specify what the label should be in the invitation, assign some other metadata to it, and optionally selecting whether the connection should be formed through a mediator. Again, we won't be modifying any of these values. We do want to make sure that the auto accept is flagged as true. So it'll be the blue background on that one. And then we are ready to create a new invitation. So when you click that button, you should see some activity going on in the background as we make requests to the agent and trigger different interactions. After clicking that create new invitation button, you should also see a list item show up in the invitations list up above. If you do not see the list, it's possible that you've got a connection timed out or something. You can refresh the list by pressing the refresh button manually. By clicking on the list item, we get a little bit more detail on what's included in the invitation. We see some of the properties of the invitation that were assigned on creation. We see when it was created. We also have the ability to create a helpful QR code that allows us to scan this from a mobile agent if we choose. In our case, we will not be using the QR code, but rather clicking the copy URL button, which will show us that the invitation has been copied to the clipboard. And then we can sneakernet this value over to Bob for acceptance. You can also expand these curly braces here to see a little bit more of the raw values that are being passed back and forth between the toolbox and the agent in order to represent this invitation, if that's of interest to you. So in connections, on the Bob agent now, we see a list of active connections. We can actually do the same on Alice as well. And we see that both of them have a connection to the toolbox. And that represents our window here actually connecting to the agent, and it's communicating over a DID. There's a reciprocating DID on the other end of the connection, which is the toolbox. It's a little confusing since we are both observing from the toolbox, but we're observing ourselves in third person, so to speak. We do not need to worry too much about the details of that connection at this point, though. So we'll go ahead and just accept that as it is. And then we will copy the invitation URL into this box here on the connections tab within Bob, and then click the add button. That was rather rapid transition from pending to active state, but there was a period of time where it was in the pending state there. It then automatically advanced to an active connection as the two agents exchanged messages asynchronously in the background. It's possible that if you're connecting to a mobile agent, for instance, where it's not scripted to automatically accept the connection after scanning the QR code, it'll wait for user input before it sends the connection. And then at that stage, you would see a pending connection for a little bit longer as we waited for the other end of the connection to accept the invitation. We can then see our connections on either end. So Alice has a connection for Bob, can see his DID, or his DID and my DID, and we see that the state is active. We can again inspect the raw details of that connection record if we choose. And then likewise on the other end for Bob. So we'll see the two roles are, inverted to represent the other end of the connection. And again, you can expand and view those connection details. So Alice and Bob are now connected. I will repeat those steps just again briefly in case you're following along at home. So I'm going to go ahead and delete both of these connections just so I don't get confused later on. And then we will go to invitations. You can see that the original invitation disappeared. That's because it was consumed along the way. By default, these are single-use invitations. We can specify a multi-use invitation if we'd like to, and then that enables multiple connections to be formed with the same invitation. Multi-use invitations are especially useful for, say, you're a mediator and you'd like to enable multiple connections to connect through the same invitation without having to regenerate one for each client that connects to us. So you could take that multi-use invitation, post it on a web page, and then anybody who would like to use your mediator after going through your paywall or whatever you have in place, they can access that invitation and then form a connection with your mediator. I'll go ahead and make a single-use invitation though. And same process, we'll expand the list item, copy the URL. Should see a little notification that tells you it's hit the clipboard, and then we can paste that value into the invitation URL box on Bob's side in the connections tab. Click add, and again went from pending to active. If we check out the Alice end, we see Bob has been restored in our connections here. So now that Alice and Bob are connected, we have the ability to exchange messages. We'll get into more interesting messages as we go along here, but let's take a quick look at just a basic message example being sent between Alice and Bob. So if you click on the Messages tab here in the agent-to-agent section, it pulls up a very rudimentary kind of chat window between Alice and Bob. Well, first you have to select which connection you're talking to. So now I'll select Bob, and now it represents a chat window to Bob. So I can type out a message for Bob, hit send, and we see that the message was sent. We can see the timestamp, and we see a little notification popped up on the other end that indicates that a message was received from Alice. So if we go to our messages on Bob's end as well, we select the Alice conversation, we see Bob show up in the list, or the message from Alice show up in the list, rather, and we can respond. And we see in real time these messages showing up back and forth between the two. So these are our basic messages being sent back and forth between Alice and Bob. Basic message is itself a protocol, as we've looked at previously when Char was going through our Didcom conceptual section. And it's a protocol that represents a basic messaging, instant messaging protocol between Alice and Bob. These are not particularly sophisticated messages. It's just basically the content itself and the sent time. But there are ongoing efforts to make more rich messaging systems out there in the world. So that's what we've got here. Basic messages are not going to be used for anything other than just real world human messages sent between Alice and Bob. So we've gone through connecting Alice and Bob. We've gone through a quick example of sending basic messages. These were all taking place using admin protocols in the background here, which enable these interactions through the toolbox. And you can look at the message history in more detail if you'd like to see some of the internals of what's going on. But yeah, there we go. So I'll pass it back to Shar to talk about our next steps.
Thank you, Daniel. So now that we have connected the agents, we can practice issuing and verifying credentials between them. As we jump into credentials at this point in the workshop, I want to mention that we are focusing on the Indy and non-creds credentialing system in this demo, which, as Sam mentioned earlier, is a Hyperledger project with this nice new logo. A non-creds enables zero-knowledge proofs and selective disclosure and revocation. These are important privacy-preserving properties that we will describe and demonstrate in this next section. Akapai is also capable of W3C credentials. We are not covering that in this workshop, but Indysio is hosting a meetup later this month on the 29th on using Akapai to issue and verify W3C JSON LD credentials. So please sign up for that. Put the chat in the link, and there's a QR code as well. So the issuer is the entity that decides which credentials to issue to whom. You might think of how a university issues a diploma to a graduating student, or how a business might issue a credential to an employee to give access to facilities, for example. In order to issue credentials, the issuer interacts with the holder, who's the person or entity receiving the credential, the graduated student or the new employee in our examples. The issuer writes to the ledger, so they put certain public information related to the credential on the ledger, so that when the holder wants to prove information that they have this credential, a verifier can read this information from the ledger and make sure that the credential was actually issued by this issuer. As Scott talked about earlier, but just to really emphasize it, a common misunderstanding is that personally identifiable information is put on the ledger. PII does not go on the ledger. This is explicitly against the agreement that anybody who writes to the ledger must agree to. It's only the public cryptographic information necessary for verification that goes on the ledger. And we'll go into depth more on, we'll show the steps and exactly what's happening there. So we'll talk about the issuer in context. This diagram, we will build it up as we demonstrate issuing and verifying credentials. It should look a bit familiar from Scott's section earlier today. And so we are using these three entities. The names are intuitive, but just to be super explicit, since the roles are very important, the issuer issues the credential. That's DMV, a university, an employer, etc. The holder holds the credential. This is the subject associated with the credential, and the verifier verifies the credential when the holder presents it. So we'll look at the first steps that the issuer takes to issue a credential. So they need to write a DID, schema, and credential definition to the ledger. And then they sign and issue a verifiable credential, and now the holder holds that credential. So these are the same steps broken down because we're going to look at each of them more closely and demonstrate them. So in order to complete the issuer's first step, we need to anchor a public DID to the ledger, write a new schema to the ledger, or we could retrieve a pre-existing schema from the ledger and then create a credential definition, write that to the ledger, and then we are able to actually issue that verifiable credential. So looking at that first step, a few things to call out before we can anchor a DID. This is calling back to what Lynn said earlier. There are multiple roles when interacting with the ledger. There's an author who can create transactions and issue credentials, but they need an endorser to endorse their transaction for it to actually be written to the ledger, and they must have their DID on the ledger. The endorser can endorse transactions to put them on the ledger, and their DID must have endorser status on the ledger. In this demo, our issuer will have both the endorser and author privileges. So we'll create the transaction and also endorse it, have it written to the ledger. And before anchoring a DID, we need to have signed the transaction author agreement. We are agreeing, like I said, to never put private, personally identifying information on the ledger. And so with that, I will pass it over to Daniel for a demo of those steps.
Cool, thank you, Shar. There were a couple of questions in the chat that I want to briefly address before we go on to talking about the DIDs, just to kind of raise them up into the call and talk about them a little bit more. So first one here, Franz asked, what is the limit and cause of the limit on the number of messages that can be received per second? That is an excellent question. So to give slightly more detail on the messages being exchanged between agents, so these are messages that are being, we have known public key asymmetric key values for either end of the connection. We then use those keys to derive a shared secret. And then that shared secret is used to symmetric encrypt the message contents into a ciphertext that is then passed over the wire. So the rate at which you're able to construct and encrypt these messages is kind of dependent on the hardware you're using and what crypto facilities are available to that hardware. It is significantly more complicated for an IoT device at this point, for instance, to engage in the same crypto that we're using right now on in this container. But the encryption, I think, tends to be the upper limit for how many messages we can emit per second. I don't have any hard numbers on that because it is a highly variable thing depending on your configuration, your setup. But generally speaking, it tends to be more the processing of the message contents and whatever actions are triggered by the messages that are actually going to be more significant. So for instance, in order to issue a credential, there's several quite CPU intensive signing operations and key generations and other operations that are taking place as a result of a message being received and prior to a new message being sent. So raw messages per second isn't really a common metric that I think we throw around within the Hyperledger Aries ecosystem, but it is certainly an interesting metric to have. Sam also kind of addressed this question already, but again, just to raise it to the recorded video, just for the benefit of others, how would we go about going beyond one-to-one communication? So this is a subject of ongoing conversation within the Didcom working group about the right way to handle group communication. The Didcom v1 specification technically allows for us to send messages that are encrypted to multiple parties. But that's I think, generally suboptimal in the wider context of group communication. We only have, I think, mutual authentication from one point to the next. And when we go to group messaging, there's some cryptographic breakdowns in that certain group exchange. So there's ongoing conversations there. This is actually quite a recent thing that's been seeing more intense discussion. So if you're interested in being more plugged into that, I highly recommend listening in on Didcom working group and user group calls, which occur on Mondays. And you can find more details in the diff calendar for that. Yes, one other thing I will briefly discuss as well. Using Didcom, you have a very multi-purpose, useful, secure, mutually authenticated communication channel, which means that we have pretty strong assurances that the person on the other end of the line is the person that we think they are, which is something that isn't the case with a traditional client-server model. We only have strong authentication on the server side and not on the client side, unless you have client certificates, which is a whole other thing, I guess. So taking advantage of this really valuable cryptographic pairwise connection that we have, we can negotiate communications through other existing communication channels. So an analogy that I recently explored on the subject, it's like you have messages being sent by mail going back and forth between Alice and Bob, as an example, and say Alice and Bob are sealing their envelopes with their special wax seal or whatever. So they know that it came from Alice because that seal is as expected. Analogy breaks down if you look at it too closely, but it holds for a high conceptual level. It's basically the equivalent then, negotiating a separate communication channel. It's basically the equivalent of saying in a letter from Alice to Bob, here, call me at this time at this number, and we'll have a live communication over the phone. A similar process can be used within the Didcom world to bootstrap communication through another mechanism. And then you can also negotiate using Didcom, whatever security or other secrets that you need in order to make sure that you're actually talking to the person you think you are once you switch communication channels to that other negotiated system. So yeah, there's definite opportunities for bootstrapping communications using different methods and such. Cool. Okay, so with those questions addressed, returning to anchoring DIDs and preparing for issuing of credentials as a result. So first, we will be using Alice as our issuer for these interactions. As Shar talked about, the issuer role is a role. It can be, it's not strictly required that any particular kind of agent fulfills a role. It is a little weird that we have somebody that we are talking about as an individual being an issuer. That's not typically how it works. Usually it'll be a public organization who has good reason to put public values on the network. But for our purposes, we'll use Alice and Bob as issuer and holder, rather, just for simplicity in our demonstration and setup for today. So Alice will be needing to create a DID and then submit it to the network that we are using for our demonstration today. So in order to create a new DID, we'll go to the DIDs tab. And before I click on this, I'm going to briefly prime you for what comes next. So DIDs require that we sign the transaction author agreement required by the network. So since the DIDs tab has some operations that result in transactions being submitted to the network. Before we are able to submit any values to the network, we must first accept the transaction author agreement and make sure that that acceptance and a representation of that acceptance is included in all subsequent transactions. ACPI handles most of the details of that for you. It's just a matter of hitting the right endpoints to store our acceptance within the wallet, and then ACPI ensures that those are all included on transactions thereafter. So when I click on the DIDS tab, it will pull up a pop-up here that says transaction author agreement. Using this module requires signing the transaction author agreement. So if we click through, hit continue, we can then see the text of the transaction author agreement. You can have fun reading through the agreement there. I shouldn't mock too much. It is an important agreement. You should read these and understand what you are agreeing to and writing these values to the network. Basically, it boils down to that you will not put anything that's inappropriate to put on the ledger, such as personally identifying information and such. So when we've read through that, we can accept the terms of the transaction author agreement and hit submit. And now we are ready to interact with the DIDS tab in the toolbox. So there are 3 DIDs that already exist within our agent. These DIDs represent a pairwise connection. These are the DIDs that were created in order to represent the connection with the toolbox, our first connection with Bob, and then our second connection with Bob. We actually deleted the connection value itself, but the DID is still here and available in case we used it for other purposes. But yeah, these are our DID values. In the future, these will be explicitly peer DID values. At the moment, these are something resembling peer DIDs. They are values that are not written to a ledger anywhere. And there's a deeper discussion on that I won't get into at the moment. But that's why we have 3 DIDs available here within my view. We will then create a new DID. I'm going to assign a label to the DID just so we can easily identify it as the one that we've written to the ledger later on. So I'll say that this is labeled as public. You can explicitly set a DID value. This is generally not an encouraged practice. This will actually be explicitly prohibited in future iterations of the DID method specification, especially as we transition to the Indy DID method as a community. But that is possible. You can also specify the seed, similar to how Lynn was talking earlier about when using the Indy CLI, you can create a DID and specify a seed. You might not have talked about that actually. I might be remembering wrong, but you can specify a seed, and this allows us to recreate the DID in a separate wallet later on if we need to, which is sometimes a useful feature, especially as we bootstrap new issuers on a network. I will leave the seed empty, however. We do not need to deterministically generate this DID using a seed value. So next I will hit create DID, and then our DID pops up in the list. We can expand these list items. We see that this one has a DID value, a metadata with a label of public associated with it, and then a ver key value. Okay, so from here we've created a DID, but it currently exists only within the wallet. It has not been written to the network yet. So in order to get it onto the network, we require the assistance of another entity that already has permissions to write to the network, which in this case will be the Indysio SelfServe application. The link to this is in the handout if you're following along with me. I'll also paste it in the chat here. But this is where we can take our DID and our ver key and get that submitted to the ledger with a role that allows us to write our subsequent transactions ourselves. So I'll copy the DID value, paste that in here, and I'll copy the ver key value and paste that in there. And then we hit submit.
We're not seeing the interface.
Sorry?
We're not seeing the interface. I don't think the tool that you're talking about, the Indy SelfServe.
Interesting. Oh, odd. I wonder why that is. 1 second, and I will rectify that. Oh, Did it pop up?
Now we can see it.
No, it went away. That's really strange. Okay, just a moment. I will bring up a separate browser. Give that a try. Okay, I'll make that a little bit smaller, and I will get that URL placed in here. Thanks for the heads up on that one, Lynn. Yeah, so here is the self-serve page. Yep. Trying to hit that corner. There we go. I just did this on my other window, which isn't showing up for whatever reason. But I will mime as though I was submitting it anew. Just gotta clean up my windows here a little bit. Okay, there we go. So what I did was I took this did value and pasted it into the did field in this var key value and pasted it in there. And there we go. I already hit submit in my other window. It was submitted. I think if I hit it again, it would tell me that the var key was already found on the network. So probably wouldn't be too happy with me. So I'll refrain from hitting the submit button. But we now have successfully written our did to the Indy CO test network using the self-serve tool. So now that we've written that did to the network, and since we did it out of band using the self-serve tool, we don't actually have any explicit indication back on the agent that it's ready for us to activate it. So we need to trigger it to activate the did. So it will use that did for our future ledger writes that are going to take place. We see that there's also a drop down here that we can use to select the did to use as the public did. It would have been helpful if it used the label instead of the actual did value. I guess that's a feature request for the toolbox, but I know that it was the 7AF one, so I'll make sure that is selected as our active did. All right, I think we are ready to move on to our next step. So I'll pass it back to Shar for a little bit more from her.
Great. Thank you, Daniel. So the next step is to write or retrieve a schema. A schema is the data organization structure that defines the attributes in a credential. So for an employee credential, for example, the attributes in the schema might include last name, first name, address, security clearance level, date of hire, things like that. And on the right, this shows what a schema actually looks like. It has a schema name, version, ID, and shows the attributes. In this simple example, we just have first name, last name, age. The schema ID includes the did under which it was created. The to identifies it as a schema, and then it has the schema name and version included in that. And then after we've written a schema to the ledger, we can see it on the ledger using the indyscan tool that Lynn talked about earlier. And if you are retrieving a schema, this is where you'd go to retrieve a schema ID in order to use it to issue a credential. So from the schema step, the next step is to use that schema to create a credential definition. A credential definition creates the issuer-specific cryptographic keys necessary for issuing a credential. So the schema is a collection of attributes in a credential, but it's not associated with any entity. The credential definition is what binds a schema to a specific issuer, so that when the holder is presenting their credential, the verifier can see that this credential was issued by this specific issuer. Creating the credential definition generates cryptographic keys for each attribute with a public and private portion. The public portion is stored on the ledger with the schema. This is what allows the verifier to verify that the issuer issued this credential. The private key is maintained by the issuer, and the issuer uses these private keys to sign each attribute. You might wonder why we need a key pair for each attribute rather than one key pair for the credential as a whole. A little earlier, I mentioned that we are talking about a non-creds here, and a non-cred supports selective disclosure, which is when I present only some, but not all of the credentials in an attribute. And so we need to have keys for each attribute because, and we will demonstrate this, I might choose to only reveal a subset instead of all of the attributes in a credential. So that's why each attribute needs its own individual pair. We can see on the left what the credential definition looks like. We see that it has a credential definition ID. It shows the schema ID of the schema that it was created from, the attributes that we entered in when creating the schema. The credential definition ID includes the DID of the issuer. The 3 identifies it as a credential definition. The CL refers to Kamenisch Skienskia, the creators of this digital signature. And then it also includes the schema name and version. Here, the DID within the schema ID and the credential ID is the same because it was the same entity under the same DID that created both the schema and credential definition. If we retrieved a schema from the ledger created by another issuer, we would see that the credential definition ID begins with our DID, the DID of the agent that retrieved the schema and made it into a credential definition, but that the schema ID included in that credential definition will still include the DID of the creator of the schema. And yeah, this goes just to really emphasize what we've said earlier about how no PII goes on the ledger. This is the information that the issuer writes publicly to the ledger. The issuer's DID, schema, and credential ID are essential to issuing a credential, but what they provide can be more thought of as a blank template, and that is what is publicly available. So the actual values, your personal information that you would fill into that template is never available on the ledger. So with that background explanation, I will pass it back to Daniel for a demo of writing, creating a schema and creating a credential definition.
Cool, thank you. So we will return to our Alice agent window here, and we are going to get acquainted with a new tab on the left menu here. So we will go to Credential Issuance. This is another one of those windows where if you hadn't already, this would have triggered a transaction author agreement pop-up to make sure that you've accepted the TAA before proceeding to engage in operations that would result in a transaction being written to the network. Let's see. We then have the ability from this view to create schemas and credential definitions. So starting off, we first need the schemas Shar just described. We create a schema with any name that we choose for our schema. Let's go for an example today as an employment schema. And we'll say it's version 1.0. And then we can click on the Add Attribute button to add additional attributes to the schema. So from here, this is where we define what attributes we expect to find within credentials issued from the schema, with the schema. So let's say that we want to include first name, we want to include last name. Let's go with date of hire, sure. And we'll go with, let's say that you need a clearance level in order to access some building on this organization's campus. So we'll have a clearance level as well included in this employment credential. Cool. So with these values, we'll have 4 separate attributes. These names are significant in the context of the non-creds credentialing ecosystem. These are the values that the verifier will request from a holder in order for them to prove these attributes. So it's important that we do our best to reuse schemas so we don't have, a million different iterations of first name, maybe a value first that represents the same thing, kind of localizing around schemas that fulfill the use case that we need, and then allowing reputation to be developed around these schemas helps us to know what attributes to request as a verifier. It's also possible, though not presented within this UI, to specify multiple name attributes that we're expecting. So if we did know of several credential values that had multiple acceptable attributes for the same information, essentially, we could say that this could be represented as first name without the underscore, first underscore name, or given name, or whatever it is. And then we can further restrict those values based on specifying which credential definition ID we expect these to be from. This is less of a problem in an ecosystem where you are both an issuer and a verifier. You know what attributes you've issued, so you know what attributes to ask for when you're verifying. But again, this also kind of gets into the concept of having an established governance framework. You know what attributes are out there for your use case, and have made use of existing schemas on the network to help you accomplish your goals. Okay, that's enough rambling about the schema. I will go ahead and hit confirm, which will cause a schema to be created, schema transaction to be created, and then submitted to the ledger. And then we see a record of that schema that we've created available to us here. So now that we have a schema, we can now create a credential definition. So if we click on the create button on the credential definition section here, we can select an employment 1.0. That's the schema that we just created. We have the option to do revocable credentials. I won't click through those this time around. Again, revocation is a whole other discussion that we could have. So I'll reserve that for future opportunities to meet and discuss this functionality of a non-credits revocation. So we'll keep it simple for today. And then from here, all I have to do is hit confirm after specifying the schema. This one takes a significantly longer time than the schema in order to write. There's a couple of reasons for that. As Shar mentioned, there's an individual key pair for each attribute within the credential being created. And in the CL signature scheme, these are RSA keys, which for those who are not cursed with this knowledge, RSA keys are prime numbers, large prime number values that just take more effort to generate than elliptic curve cryptography does. So those are large random numbers generated representing our RSA key pairs for each of those attributes within the credential. I should clarify, I've gotten into the weeds, so I apologize, but I should clarify that the signatures used for these credentials when they are actually issued are not RSA signatures. They are the CL signatures that are critical for the abilities to do selective disclosure and private holder bindings with anonymous credentials. So we use RSA key values, RSA-like keys, but using a different signature scheme. Okay, so we've walked through creating our own schema. I will briefly take a look at what it looks like to retrieve a schema from a network as well. So we're using the Indysio testnet. So I'm going to click on that, click on the domain, ledger, subledger, and then I'm going to filter by schema. And I can see the schema I just created. Somebody else must have created one following along. I'm going to come and grab a random schema schema ID here. So I just selected one, no idea who's written this. But then if I scroll down, there's a transaction ID section. This might be somewhere else in the text. I know that I can find it there. Again, could have been up here somewhere, and it was right there. Anyways, so we select transaction ID. And then from the toolbox, we can put that into this text box here that is on the same line as the schemas. And then I can hit retrieve. And similar to the ones that we created ourselves, we see a schema up here inside of our wallet. These are just local representations that are useful for being able to quickly recall the attributes associated with the schema when we're doing the actual credential issuance, making sure that we populated all those attributes and such. But yeah, this is a local representation of the value that was published to the ledger by some other party. Using that schema after retrieving it, I can similarly create a credential definition from that value just by selecting it, hitting confirm. Again, takes a second as it creates those keys. Sometimes if it doesn't show up even after a sufficiently long time, you can hit that refresh button, and most of the time it'll show up in that list. If not, then there might be some ledger permissioning issues. You might have forgotten to write your DID to the network, for instance. So that's an important step to remember. All right, so we've created a credential a schema and a cred def for both a value that I've written and a schema that I've retrieved. Let's do one more quick schema just for the sake of demonstration and for repeating these steps for anybody that's following along at home. Let's see. Let's do a bit of a joke one here this time around. So let's say table tennis tournament win. Sure. Version 1.0. Let's say we could include first name, last name. Those are also values that we could pull from another credential held by the same holder, and we can get into that in a moment. So I think all I'm going to include on this one is I don't know, division 1, whatever that might be, and I'll make this a very simple schema with just the one attribute. Then I'll create a cred def from that schema. Confirm. Should show up here any second. Okay, had to hit refresh that time. That's cool. Okay, and now we have a cred def available for that table tennis tournament win. I've inadvertently made a tongue twister there. Okay, so we are now ready to move on to our next steps. So I'll pass it back to Shar for walking us through those.
Great, thank you. If I won a table tennis tournament, I would certainly want a verifiable credential to be able to prove it. Okay, now we are ready to actually issue a credential. So to orient ourselves back in the diagram that we're building up, now that we've written a DID, schema, and credential definition to the ledger, we've done everything we need to do with respect to the ledger. Now we can actually issue the verifiable credential to the holder. So just to review what a credential definition, or excuse me, a verifiable credential is. It is a signed statement with attributes about a subject. It contains metadata about the credential, attributes about the subject, and proof, the signature from the issuer. And so we will now look at the message flow that occurs between the issuer and the holder in order to issue a credential. A quick note that the language here is a bit awkward and not how people would naturally talk about this interaction, but this is the language used in the messages that are sent back and forth. So we're wanting to show the developer language around this flow. Like Daniel mentioned, we want to leave the guts exposed a bit to demonstrate what's going on. So this interaction can be initiated by either the holder or the issuer. If the holder is initiating, they can propose a credential. The issuer in response would send an offer credential message back. Alternatively, the offer credential message could be the start of the interaction. Either way, the flow is the same regardless of who initiated. And this is actually the offer credential message that we looked at way back when we were first talking about Didcom. So from there, the holder then sends a request credential message. Then the issuer sends an issue credential message. Once the holder receives that, they send an acknowledgement. Once they've sent that, their side of the interaction is complete. And once the issuer receives that acknowledgement, their side of the interaction is complete. And so now I will turn it back to Daniel for a demo of actually issuing the credentials.
All right. So a brief question from Matthias. I don't know how to pronounce your name. I apologize. And this might have been said in jest, but I think there's a real answer to be had here. The question being, is there a step before issuing the credential that involves a table tennis tournament oracle? So usually when we issue a credential, we've kind of, especially as we go through our demonstration today, we've omitted a few of the key steps in the issuance of a credential that most issuing bodies would be going through in order to actually validate that the information that they're sticking into that credential is authentic and real. For instance, before you can get a driver's license, you have to first present like your birth certificate or something. So there's a vetting process that takes place in order for the actual issuing organization to make sure that the credential that they're issuing is valid, and it's up to the issuer to ensure that they've implemented a rigorous enough process to validate that information. However, it is also valid to point out that any issuer does have the ability to issue any attribute. So it's important when you are requesting verification from your provers in your ecosystem that you make sure that you are validating that the credential was issued by an organization that you trust. And we can get into a little bit more detail on that as we start talking about the verification steps. Okay, cool. So we have all of the necessary pieces in order to start issuing credentials from Alice to Bob. We're connected, we've got that schema and CredDef. So it's just a matter of pushing a few more buttons here. Before I do that, let's do a quick introduction to the My Credentials tab in Bob's window here. So this is the receiving end of the credential issuance section from Alice to Bob. So Bob, when he receives that credential, should see that it shows up in his list of credentials here. We also have a credential definition retrieval mechanism here. This looks similar to the schema retrieval on the credential issuance side. This enables the holder to send a credential proposal to the issuer. Having strictly resolved the credential definitions is not necessarily a requirement. What it's doing is just getting the values associated with a credential definition into the wallet, into a place where the Toolbox UI can say in a credential proposal, these are the values that I would like in this credential and have it be from this credential definition. So that was the beginning of the flow where the holder starts it that Shar went through. We won't be demoing that today, but it is possible for the holder to start the interaction using that proposal. Okay, so to actually issue this credential, we will start from the Alice side, again on the credential issuance tab, and we will click the issue button on the issued credentials list. We will select a connection to Bob. We will select the credential definition. I've got 3 available to me since I've written 3 different credential definitions. Let's start off with our employment credential. We could say that this was issued the date Bob was hired, I guess, and we can say congrats in this optional comment on the issued credential message. So we could say Bob, his date of hire was today. I'm representing this value as a string value. This has significance when it comes to the usage of predicate proofs. I'll talk about that a little bit more and why this format for the string actually isn't ideal. I'm just doing it so I can easily put a value down here. For the clearance, for this one, I will make this a little bit more prepared for doing predicate proofs. So this one will say that clearance level, there's say 4 different levels, and each of those levels are represented with integer values starting from 0 going to 3. So we'll say that Bob has a clearance level of 1, which means he's got basic clearance 1 step up from no clearance. So I'll go ahead and issue that credential, I think. Yeah, we'll hit confirm. We'll see a value pop up here on Alice. We'll hit the refresh button on Bob, and we see the issued credential on either end of the exchange here. So if we inspect the credential value, this helps us see a little bit more of what actually took place between Alice and Bob. If you'd like to dig a little bit more into the protocols that take place here. We see, for instance, that the final state of this record of this issued credential is credential act. This is the completing state for this credential, and represents that we received acknowledgement back from Bob at the end of the full exchange of the message that he has received that credential. We have a record of the CredDef ID and scheme ID that was used to issue the credential. We can see the attributes that were issued, and we can also dig into the raw developer values as well here. For instance, you can see like the raw credential offer message that was sent to Bob from Alice, which includes the credential preview, which is where the attributes are actually located. If I were to expand all those. And then from the recipient end, we see a similar set of information available to us. So again, state credential act, CredDef, scheme ID, the attributes that were issued. We also see an additional value in here in the record, which is interesting. So I'll bring it up, which is the actual raw credential value. This is what gets stored into the wallet so that we can later fulfill presentation requests with this credential. This credential storage is separate from the record that represents the exchange between Alice and Bob, just as a side note. So the exchange record, the values that track what our state is in the protocol, can be thrown out by either side of the exchange. It doesn't matter. It's not necessary that we keep all of this information around. What matters is the actual raw credential value here, which includes, values and signatures, which is big stuff significant to the CL signature scheme. All right, let's see. I will issue one more credential just to walk through this process one more time. So from Alice to Bob, I will now again select Bob as the connection. This time, let's go with a table tennis tournament win. And we'll say this was in the, I don't even know what division represents in this case, so I'll just come up with something. We'll say it was a division within a company. Let's go with that. So we'll say it was on the tech staff that the tournament win was made. We'll omit the comment and we'll go ahead and issue that credential. And then if we review our values here on Bob's end, we see the table tournaments. Geez, can't say it. I'll just skip it. We received the credential. So now I think we are good to talk about our next steps. As a brief reminder, all of this information will be in the slides that will be shared out. So if you want to step through again later, there will be screenshots in the slides if there are any steps you want to repeat. So with that, I'll hand it back to Shar.
Great. Thank you, Daniel. So now we are moving on to verifying a credential. So whereas the issuer had to decide which credentials to issue to whom, the verifier must decide who and what to trust. So to decide this, they interact with the holder, they read from the ledger, they perform cryptographic computations to verify that the attributes presented were issued by the specific issuer. An example of a verifier might be the airport or the bank or a store, anywhere where you need to prove information about yourself. What the verifier does not do is interact with the issuer. The verifier is only able to read the information written on the ledger by the issuer. So there's that indirect interaction that provides that trust. For the sake of simplicity, we're having Alice play the role of both the issuer and the verifier in this demo. Roles are not set permanently between parties. The role is unique to the interaction, so that works just fine. It's also entirely possible that the issuer is the verifier. If an employer issues an employee credential, they would probably want to be the verifier as well in some cases. But if they are different, it's important to emphasize that they do not interact and cannot gather or exchange information without about the holder without the holder's consent or knowledge. So back to this diagram that we've seen before, we're now moving to the right side on the verification side. So first, credential must be created, and then the verifier reads the DID schema and credential definition from the ledger and verifies the attestations. And now we have built this diagram to completion. So here, again, we will run through the flow of messages necessary to verify a credential. And again, either side can initiate this interaction with a proposed credential message from the holder, presentation request message from the verifier, and then the holder can choose to approve that request and send a presentation in response. Then the verifier will verify that presentation and send an acknowledgement, and then the holder will receive that, and then both sides of the interaction are complete. And before I turn it back to Daniel for the demo, I will talk about the different types of presentations. So the simplest example is a full disclosure presentation in which all attributes are revealed from one verifiable credential. So in the analog world, the equivalent is where you take out your passport at the airport to get through security. You're showing all of your information on that passport. Another type of presentation is the multiple credentials presentation, where you reveal all the credentials from 2 or more credentials. Another example in the analog world, when I got a library card after moving, I had to present a photo ID and a piece of mail proving my address, and revealed all of those attributes. So moving along to more complex types of presentations, these show off the important privacy features of non-creds. There aren't really great examples of these in the analog world because they are unique to this digital interaction. So selective disclosure is when only certain required attributes are revealed from one or more credentials. So instead of revealing the entire contents of a credential, you reveal only a subset of the attributes. A predicate proof presentation is when only a true-false value is revealed. A common example is age. The verifier doesn't need to know your date of birth, which is a very important identifying piece of information. If all they need to know is if you are younger or older than whatever threshold they need to make a decision, if you can enter the venue or get a senior discount or whatever the case may be. So this is a great way to preserve privacy while verifying necessary information. And lastly, revocation is the ability to revoke a credential. For example, if a credential expires or needs to be updated, or the holder is no longer eligible for whatever reason. And so with that, I will pass it back to Daniel for a live demo of the different types of presentations.
Okay, before we get into it, I acknowledge that we are actually at time. So I apologize, we've run a little bit behind schedule to this point. If you have to drop, totally understand. We will stick around and continue to finish the rest of the presentation, perhaps a little bit more accelerated. So those who would like to stick around can do so with a little bit less burden. These, again, will be in the slides. So if you've got to drop and you don't want to watch the video later, the slides will have a walkthrough of these last few steps as well. So I'll proceed here slightly quicker than I have previously. So from the Alice end, we click on the verification tab. And from here, we can request a presentation from one of our connections. We will select Bob. We will select a name. Oh, we've got somebody off mute. There we go. All right, let's see. We can assign a name to a presentation request. Let's go with just a simple Well, let's do a multiple disclosure. So let's do a proof of table tennis tournament win. Geez. So we will request the attributes that we issued. I think we gave a division, but we might also want to verify that the person who won the table tennis tournament is actually an employee of the organization, just so they can get a prize or something from the company. So we can ask for first name and say last name. And we can ask for date of hire as well. So we can apply restrictions to these values that we are requesting in this presentation request. These enable us to say, I want this attribute from this specific individual, or rather from the specific issuer, and then be able to cryptographically require that as part of the verification process. So this is the scenario in which we actually need to determine who we trust. So the ice cream truck that I frequent down the street might have given me a rewards card that has my name on it. But as an organization, we're unlikely to trust the verification processes that the ice cream truck went through in order to issue that credential to me. So we want to make sure that we are using issuers, trusted issuers that are appropriate for our use case, for our governance framework, and so on. So for this one, I'm going to require that it came from the table tennis tournament credential, and from this one, from the employment. Same with this one, same with that one, and hit confirm. Okay, and we saw that it went from unverified to verified as the exchange took place between Alice and Bob in the background here. You can again examine these values in more detail. The revealed attributes are presented to the controller and to the toolbox in this case. It is using these revealed values that we would then take our next step in our business logic operation, whatever is going on. Purely because a value is verified does not necessarily mean that we're ready to act on it. We might want to make sure that in our business logic that the division was one of a set or something like that. So this isn't necessarily the end. There's more to do after that value has been passed up to your controller in order to trigger the next step in some exchange. I will now do a quick predicate proof just to demonstrate that real fast. And this will be, say Bob is attempting to access a building on his employer's campus. So we'll ask for a proof of clearance. And we will request a predicate on clearance. And we say that it must be at least a basic clearance level. So we'll put in the value that represents the basic clearance level, specify the restriction, hit confirm. And we see that that presentation has verified successfully. We can view these presentations on Bob's side as well. I won't get into the details on that. This verified true statement that the predicate proof was met, and that representation of that predicate can be seen there. So that brings us to the end of our hands-on demonstration. Thank you everybody for your participation. I'll hand it back to Shar for some concluding thoughts.
Great, thank you, Daniel. So to look briefly back at what we've covered, we've discussed agents, Aries Collaboration in Python, and the Aries Toolbox, Didcom messaging. We've demonstrated how to connect agents and issue and verify credentials between them. We also way back covered an intro to decentralized identity and the Hyperledger Indy project. This is the end of the Aries section. Thank you all for listening and engaging, for following along and asking questions. I will now pass it over to Sam for a final word on getting involved.
Thanks, Shar. I just want to encourage everyone. You're hearing from me again about community involvement, but we'd love you to be involved. If you're interested, come and learn. If you're able to contribute, that's wonderful. Ask questions, reach out to any of us if we can help, and we'd be happy to do so. You've got some, we've got links on the channel, and the Discord server is a great place to get started and join our meetings. Thank you for coming today. I hope you learned. I hope this was interesting, and we hope to be able to help you as well in the future. Thanks so much.
Thanks everyone for joining, and thanks to everyone for Indicio for running this. I think this went great. Bye all.